Hi, my name is Bob Tabor with www.learnvisualstudio.net. Welcome to this fourth and final course in a series of courses on the fundamentals of Microsoft Azure. And I've titled this course Virtual Machines, but that's kind of a misnomer. Yeah, for about half of the series, we're going to learn about the features of virtual machines and virtual networks and how to configure the various features available in both of those. However, in the second half, it's kind of going to be the catch-all for all the topics that I couldn't fit easily into any of the other courses. So after we talk about VMs and VNets, then we're going to spend several modules on popular services like Microsoft Azure Mobile Services. Then we're going to start to take a whirlwind tour of the most popular services on Microsoft Azure, just at a very high level. I'm not going to go into much depth. Just a 50,000 foot level overview, not a lot of detail, but hopefully you'll be able to, from that height, see the landscape of the product in general. Now, if you started at the beginning of the series of courses with me, then you're doing a great job. Wow, that's awesome. We're almost to the end of our work together, so hang in there. However, if you're just jumping in here and you haven't watched the other courses in this series, don't worry. Nothing we discuss in this course is really dependent on those other courses per se. Even if I make a passing reference to topics that we talked about previously, I don't think it's going to be required knowledge. But if you do encounter something that you don't understand, by all means, look through the other topics in the previous courses or just search for it on Azure's own documentation. So up to now, we've only looked at Microsoft's platform as a service offerings, but now we're going to delve into Microsoft's infrastructure as a service products. And as they say, without further ado, let's jump on in and let's get started with some of the conceptual background on virtual machines and related infrastructure as a service concepts. And then we'll move on from there with some actual hands-on demonstrations. So I'll see you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll introduce Azure Virtual Machines. And if you recall from way back in the first course, maybe the second or third module, I discussed the difference between platform as a service and infrastructure as a service. And I said that there's a lot of different ways that you can architect an application, a solution for a business problem. And the type of solution that you choose will be based on how much control that you need and how much responsibility that you're willing to take on. So, for example, with the platform as a service offering, like Azure Websites, for example, we created a website in Visual Studio, we deployed it up using Visual Studio's tools, it was very easy, and then we're pretty much done. I mean, the only other thing we had to do was decide if we wanted to turn on auto scaling or manually scale, but for the most part, we had really no other responsibilities in the system. All those mundane administrative tasks were taken care of by the Azure team. Now that also means, however, that we were limited in the amount of control that we had over how that environment worked. So for example, we couldn't install some custom third-party software on that computer that's hosting our website because we didn't have control of the environment. So on the other end of the spectrum, we could always opt for an infrastructure as a service offering like Azure Virtual Machines, and that will give us total control over the operating system configuration, disk persistence, what software we can install on the server, and so on. Now, of course, that comes at a price. That means that we're responsible for server software installation and configuration and installing security patches and any other updates as well. So again, it's that balance between responsibility and control and how much tolerance we have for each. So when we talk about infrastructure as a service, we're really talking about Azure Virtual Machines and virtual networks. That comprises pretty much the entirety of Microsoft's infrastructure as a service offering. And so it's going to comprise the first half of this course as well. And virtual machines really represent the very first steps that most companies make into cloud computing before they start diving in and architecting software solutions around platform as a service offerings. They instead will perform this operation on their existing systems called lift and shift. So they'll take existing software systems on their on-premise servers and they'll lift them and shift them to a virtualized environment inside of Azure as a first step, getting their feet wet to kind of extend the data center. However, they don't really have any huge commitment to that data center. They could move everything back if they wanted to. So this series is all about virtual machines and virtual networks. Let's define exactly what a virtual machine is. First of all, a virtual machine is simply an emulation of physical hardware. It's software that's acting like it's hardware so that you can run software, operating system software, basically in the context of another operating system, the host operating system and the guest operating system. So kind of to get a little bit deeper than that, there's the software system called a hypervisor. It's often referred to as well as a virtual machine monitor, and it runs typically on a cluster of physical hardware. Now, we can run a hypervisor on our own local computer or on a really beefed up server, but typically we're talking about multiple machines that are clustered together. And so then there's this abstraction layer between the physical machines and the guest operating system, and that's the hypervisor software that I talked about a moment ago. That abstraction layer is sometimes called fabric. If you think of each of the individual computers as a thread in a larger piece of fabric, well, that's kind of the notion here. So the fabric layer allows you to combine the computing power of many physical machines, what Microsoft often refers to as commodity hardware, relatively cheap computers. And it combines them all together, clusters them all together to give you basically a lot of computing power when combined. And so then you go out and you say, okay, I need a new virtual machine that emulates this kind of processor, it has this much memory, it'll have this much disk space, and so on. And then Hypervisor, or Hyper-V, which is Microsoft's version of the hypervisor software, Hyper-V will go out and it will allocate all of those resources to a new emulated host, and then you begin to install the operating system in that host. So it's allocating a small fraction of all of the computing power that's been clustered together to host a single emulated system. So to the guest operating system that gets installed, all it sees is a computer. It doesn't know if it's a physical computer or if it's an emulation of a physical computer. And so this little technique of clustering computers together and then allocating some of the resources here and some of them there, it allows a company to quickly provision new emulated servers or to shift resources on demand. So say, for example, you have one application that is under heavy load right now, and you have other applications that are inside of your virtualized environment that they're not under heavy load right now. You can shift resources and scale out and scale up the virtual servers that need more horsepower, more RAM and hard drive space, or whatever the case might be. And so this allows you to effectively use less hardware in the long run because you're just shifting what is working on a smaller set of hardware around as needed. And so there's a couple of different benefits. I've already gone into one of them, quickly provision and to scale. Another huge benefit is that if one of the physical machines in the fabric go down, so maybe a motherboard failure or a network card burns out, the fabric layer will begin to transition all guest virtual machines that utilize some part of that physical computer to the other hardware in the cluster. So you minimize downtime due to hardware outages. Now, you might think that this description sounds a lot like Microsoft Azure, and you're correct. Azure is just a virtual environment on a very, very large scale. Azure has been described basically as a cloud layer on top of a number of commodity Windows Server systems. So the fabric layer uses Windows Server and a specialized version of Hyper-V for their own custom use, and together it's known as the Microsoft Azure Hypervisor, and it provides virtualization services to us all, whoever needs a new virtual machine or anything else inside of Azure. And the idea of virtual machines and virtualization has been around for a very long time. Many companies already have a virtualized environment that they can use to move available computer resources around to the different servers as the need arises. The only difference here is that whenever you worked in a virtualized environment with Microsoft Azure, there's no cash outlay for new hardware. Microsoft's already made that investment. And furthermore, there's no need for the company's engineers and administrators to build competency and exert effort to manage that fabric layer. That's what Microsoft does for you. Instead, all of your engineering talent can focus its efforts on the applications that serve your business and just treat the Azure virtual machines themselves just like they were any other server in the company's networked environment. So besides the freedom from purchasing physical hardware, which most of it, let's be honest, it loses its value immediately after it leaves the factory, and besides the freedom from setting up and maintaining the virtualized management layer, companies can also, as a result, move more quickly. And this is one of the key benefits to using any cloud-based vendor like Microsoft Azure. Let's say, for example, that for whatever reason you need 100 new servers and you need them tomorrow. You can do that. You don't have to wait weeks and months. And what if you only need those 100 servers for like 3 days? Well, then you only pay for that time, for the 3 days that you need them. And then the last benefit to using Azure virtual machines over, let's say, on-premise virtual machines that I'm going to highlight here is that you have a vast number of base images to choose from. So whenever you create a new virtual machine, you can select from dozens of pre-configured virtual machine images in what they call this gallery. And the gallery hosts Windows images, various Linux images, and images that are pre-configured with SQL Server and SharePoint, and various third-party solutions like Oracle software and things of that nature. So this reduces the time to go live because a lot of those setup steps are already done. You might need to do some little configuration on them, but they're ready for you to use immediately. And you can even create your own images after you've configured everything so that if you need new virtual machines in the future, based on all your configuration changes, all you got to do is show up in the gallery. We'll talk about this in just a moment. Very cool stuff. Okay, so let's talk money. One of the biggest considerations whenever you're utilizing virtual machines in Microsoft Azure is the cost. So just like every other Azure service, it really comes down to how much you're using. If you need more resources, you're going to pay more. If you need fewer resources, you're going to pay less. And so you can set up a really small virtualized environment for a couple bucks a month. Or if you need thousands of virtual machines running in the cloud, then obviously you're going to pay a lot more for that. At the time that I record this, there are 4 basic components, and I'll give you a bonus, number 5, that will affect pricing. So the first thing is whether you need Windows or Linux. Windows is more expensive. The next thing is the compute power in terms of how many processors, how much RAM, how much disk space, and let's talk about that more in just a minute. The third factor is the tier of services that you want to make available to your virtual machines. So for example, there are services like load balancing and auto scaling and several more, and these are available at a premium. So there's like two tiers. There's a basic tier. It's pretty much bare bones, and then the standard tier gives you access to all these other services. And the fourth component that will affect pricing is the data center that you deploy your virtual machines into. Some virtual machines, some regions in the world will cost more. I'm not sure why, but it will affect costs. And then there's that bonus 5th component as well. So I mentioned a moment ago that there are pre-configured images that have like SQL Server or Oracle already installed on them. Well, you're going to pay a little more money for virtual machines that already have pre-configured software like SharePoint, SQL Server, Oracle, whatever. So you're paying a little bit extra for the license to use that software. Okay, I said let's come back to compute power. I want to talk about that for a moment. You have many options to choose from, and they break down into series of offerings. So, for example, there's an A series. Let's talk about that for a moment. In the A series, there's like A0, A1, A2, A3, A4, A5, A6, A7, A9. I think there's just 9. And the 0 has the least amount of RAM, least amount of processing power. The 9 has the most inside of that series. So typically the A series is configured in such a way to be general purpose. It's not recommended for any production environment applications. It's really intended to be just used for development and for testing purposes. Maybe some sort of running a bunch of continuous integration unit tests out in the cloud, on an ongoing basis. That sort of thing is what it's good for. Then there are the D series virtual machines, and these are faster. They use solid-state hard drives, for example, instead of the platters. They use faster CPUs. And then finally, there is the heavy-duty G series, and this is the fastest. It uses the most modern hardware, and it can scale up to massive amounts of CPU and RAM and storage space. And these are only available in limited data centers at the time that I record this. They're fairly new. Maybe that's the only reason why, but I believe more coming online. That's just something to check on. And again, I guess in that regard, keep in mind that this information is likely to change on a frequent basis. So you always want to just refer to the pricing page. I got a little link for you there that you can get to it very quickly. And since we're talking about money, let's also discuss two other items. First of all, even though that pricing page talks about a per hour charge, you're really only charged on a per minute basis. So if you only need a virtual machine for 27 minutes, you're only going to pay for the prorated version of that hour, roughly a little less than half of whatever that hourly charge would typically be. And then finally, you have to be careful and make sure that you know that when your virtual machine is running, you're paying Microsoft. If you don't want to pay Microsoft, then you need to shut down the machine. Now, you used to have to delete the machine a long time ago in order to save money. As long as it was allocated to you, you had to pay. But fortunately, they changed that policy. Now, if it's shut down, you're not paying. You might be paying for storage space and other things where all of your drives are sitting on, like Azure storage blobs, but you're not paying for the virtual machine to be running at that time. Okay, so whenever you create a new virtual machine, like we're going to do in the very next module, you're going to get two disks. There's going to be an operating system disk and a temporary disk. So what's the difference between the two? Well, the operating system disk is obviously going to host the operating system. The temporary disk is intended for temporary storage for like caching, like page file caching that the operating system might use in order to speed things up. And that temporary disk is unreliable for long-term storage. And the reason it's unreliable is because it's actually a physical disk that is located within the chassis of the physical server on which your virtual machine is currently hosted. So if your virtual machine for some reason gets moved to another server because of the unavailability of a given rack or machine, then you're going to lose all the data on that temporary drive. So we're going to see these drives and how they're mapped inside of our virtual machine when we actually create a new virtual machine in the next module. And also, whenever you provision a virtual machine, you're really getting a copy of a virtual hard drive. And these are one of several pre-configured virtual hard drives, or VHDs, and they're called an image. And the image is a template that's copied to a new virtual hard drive disk. And the disk is what your virtual machine boots up from as you start it up. So clearly it's an essential piece of the puzzle. And there are two types of persistent disks. There's an operating system disk, which obviously holds the operating system. It's persistent. You can store things on it and it will always be there. And then there's the data disk. And this is really the preferred place where you would put long-term data. And they're both comprised of page blobs in Azure Storage. And since they're page blobs, you get all the advantages of using Azure Storage blobs, like high availability and durability and geo-redundancy and things like that. And these disks are mounted as drives on a virtual machine. Now, in the Windows operating system, the operating system disk is mounted as the C drive, as we would expect. In Linux, it's mounted as the /dev/SDA1 partition that's used as the root directory. And then, as we'll look and see in the next module, the D drive is the temporary disk that I mentioned a moment ago that you would use for temporary purposes. The operating system's using it to cache things out, but you might also choose to use that to put some cached information that you don't expect to be there on a permanent basis. Because if you want a more long-term solution, you would attach one or more data disks. And I'm going to demonstrate how to do this in an upcoming module. Once you attach a disk, it's going to look like a blank hard drive, just as if you took a blank hard drive that you bought from Best Buy and you stuck it in your computer. It's going to look, first of all, it's going to need to be initialized, and then it's going to need a partition, and then you're going to need to format that partition. Same thing here. It's just a virtual hard drive that gets installed. So we'll demonstrate how to do that in an upcoming module. So whenever you provision a new virtual machine, you're going to want to connect to it, and you want to manage it somehow. And you'll want to allow applications to connect to it, to use any services that it exposes, and so on. So by default, virtual machines are completely locked down with the exception of connections that are allowed through a certain endpoint that allows you to do remote desktop. So the remote desktop protocol is enabled, but everything else is shut down. And so in order to communicate via other mechanisms, whether it be FTP or HTTP, or for Microsoft specific products like SQL Server Management Studio, you have to enable those endpoints in Azure. So an endpoint is simply a mapping that's created in the Azure load balancer to your virtual machine on a given port. We'll talk about the load balancer in an upcoming module. Whenever you create an endpoint in the Azure portal, you're actually configuring the Azure load balancer to allow traffic from the internet to come to your virtual machine, and you're creating a mapping between public ports on the Azure load balancer to ports on your virtual machine. And so like most of the virtual machine related tasks, it's really easy to configure. Conceptually, as long as you get over the conceptual hurdle, the how do I is extremely simple. And I'm going to demonstrate how to do some of these things in upcoming modules. Now, once your machine is actually provisioned, it will be provisioned with two IP addresses. One will be for internet-facing communication, and one will be for private communication inside of Azure only. So we're going to spend an entire module explaining the various IP addresses and how they work, and we're going to talk about the Azure load balancer and the internal load balancer and the roles that they play. And I briefly mentioned autoscaling as a feature of the standard service tier just in passing a few moments ago. I want to talk about the Azure VM's scaling story. First of all, you can scale up within a given class and tier of servers. So for example, I can scale an A0 to A3 just by selecting it from a drop-down list box. However, Microsoft recommends that you scale out rather than scaling up. In other words, you should choose to scale out and have additional servers that have the same basic configuration instead of beefing up a single server, making it go from A0 to G10, which is not even possible, but let's just say, for example, it was. I don't even know if there's a G10. Microsoft recommends using more of the same configuration rather than one huge server. And one of the reasons why you want to do that is so that you can have an availability set. And an availability set will help to keep your application running even if one of the servers goes down for some reason. So again, it's really easy to configure. The conceptual hurdle is the only thing that stands in your way, and we're going to explain more about that and demonstrate how to set up availability sets in an upcoming module. And as we're nearing the end here, I spoke a moment ago about how you can make a clone of your configured virtual machine complete with any attached disks that you've set up, which can be used as an image to create new virtual machines. It even shows up in the virtual machine gallery so that you can choose it in the future if you need another virtual machine that's configured exactly the same way. So we'll talk about configuring virtual machines images in an upcoming module. And I believe that's all that I really had to say. So to recap, I hope you can see what's possible with Azure Virtual Machines. And now the only thing that's left is for us to dive deeper to understand more about some of the concepts and actually get our hands dirty and work through some examples of how to set them up and configure them and what features that are available and what does that mean and how do we set those up and take advantage of them and so on. So we'll start down that path and we'll take this baby for a spin starting in the very next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we're going to create a new virtual machine using the Quick Create option, and then we're going to connect to it via the Remote Desktop Protocol utility application. So creating a virtual machine is really easy if you just need to create one virtual machine, and you're not going to need to scale it out, and you don't need to communicate with other Azure services and things of that nature. I'm going to demonstrate this simple case first here in this module just to get started. However, you should know that if you think you're ever going to need to eventually scale out by adding more virtual machines that will be used to handle load for a given software application, or if this virtual machine is part of a larger system that includes other Azure services, you should plan ahead a little bit. At the end of this module, I'm going to highlight some considerations before you just use the quick create option that we're going to use to create this virtual machine. Okay, so let's demo this first scenario. It's very simple. We'll go to New, Virtual Machine, Quick Create. Now you see there's the From Gallery option here. Let's go ahead and click it and you just see it open up. We're not going to use that here, but we will look at it a little bit later on. But here I could choose any number of pre-configured options, not just with the various server software, but then also pre-configured with SharePoint or SQL Server. There's also configured with Oracle software on it, and so on. Finally, you'll see that there is an area here for my images and my disks, and we'll talk about that later as well. Let's go ahead and close that option and then go back to New, Virtual Machine, Quick Create. Here we're going to need to give it a new DNS name, so it's going to be whatever.cloudapp.net. Bob's First Demo. See if that's available. It is. We can choose the image that we want for the operating system. So we're just going to stick with Windows Server 2012 Data Center. And then we can choose the size. Now here, again, I want to remind you that there are two levels of services. There's the basic level of service and standard level of services. Inside of the standard level of services, you can have a server from the various tiers, the A series, the D series, and the G series. Now, if you do choose, for example, an A1, you won't be able to upgrade it to a D1 or a G1 or a G2 or G3 or whatever. Similarly, if you pick a D1, you're not going to be able to upgrade it to a G1. So you want to choose based on what you think you need kind of right off the bat here. I'm going to choose a 1-core, 1.75 gig memory size. And I'm going to give this a username and my password that I'll want to use to log into this machine. And I'm going to choose an affinity group, and I'll just choose East US. We've talked about regions and affinity groups before, and now we'll create a new virtual machine. Okay, so honestly this can take a few minutes, so let's go ahead and let that run, and while it's running I'm going to talk about what your options are after you've used this quick create and maybe looking at other options. We just created a virtual machine the easy way. However, we might need to plan ahead a little bit if we want to take control of the virtual machine creation. So there's 4 things that we need to consider before we create a new VM just by going off and using the method that we used here. First of all, we need to think about affinity groups. So an affinity group is a way that you can group your cloud services by proximity to each other in the Azure Data Center in order to achieve optimal performance. So when you create an affinity group, it lets Azure know that you want to keep all of the services inside of that affinity group as close as physically possible inside of that data center. So for example, if you want to keep the services running your data and your code close together, you would specify the same affinity group for those cloud services. They would then run on hardware that hopefully is located fairly close together in the data center. So what this does for you is that it helps to reduce latency and increase performance while potentially lowering costs because there won't be transmission of data across data centers or things of that nature. So affinity groups are defined at the subscription level, and the name of each affinity group must be unique within the subscription. Each affinity group that you create is tied to a specific region, which is the location. The second consideration is whether or not that this virtual machine will become part of a virtual network. So if you think that this virtual machine will eventually be part of a virtual network, then you should stop down and create the virtual network first and then add the virtual machine to it. We haven't talked about virtual networks just yet. We will spend an entire module or two talking about them, but let's talk in broad terms about why you need to start with the network before you create the machine. Well, the TCP/IP addresses for Windows Azure virtual machines come from a predefined range of IP addresses. So you can just let Azure pick the IP address for you, or you can create your own virtual network that has a user-defined range of DHCP addresses, and even place a DNS server or connect up your own local network to the Windows Azure network for your virtual machines. So for this reason, you're going to want to have a virtual network in place first so you can control the IP address range. I'm not going to demonstrate how to do that in this module, but I will talk about virtual networks again later in this course. So the third consideration is that whether you need to take control of the storage account and the container that will contain your disks. So Azure Virtual Machine disks are stored in Azure Blob Storage like we talked about in the previous module, and that means that you get the benefits of blob storage that we talked about briefly. However, if you don't define a storage account and a container first before you create your virtual machine, then the Azure Management Portal will do that for you and create as it creates the machine. Now, defining that storage account and container ahead of time allows more control. For example, a better naming convention than what's automatically generated for you. And so the fourth thing that you'll want to consider is whether you're going to need to add the virtual machine to an availability set. So when you build more than one virtual machine, which is always a good idea and it's required for availability, then you can load balance the IP ports for them, and you can also specify that they're on a separate fault domain for greater availability. So this is called an availability set. Even if you think that you're only going to build out one virtual machine, you can add the availability set now as you're building it and then use it once you grow the system. In fact, the only way to get a service level agreement, an SLA, where Microsoft will actually pay you if your availability set is entirely down on your virtual machines, is to actually add them to the availability set and add a second virtual machine. Yeah, it's going to cost more, but again, you get a service level agreement whenever you do that. And so I'm going to devote an entire module to availability sets here pretty soon. All right, so to recap, we were talking about building a virtual machine the easy way and connecting to it. It's still running. Let's go ahead and wait for it to finish before we try to connect up to it. Okay, and it took about, I don't know, 10 minutes or so, and it looks like it's up and running now. So what we'll do next is to connect to it via RDP is to select it and choose the connect button in the bottom bar. It's going to want to save the bobsfirstdemo.rdp file to my downloads directory. I'm going to go ahead and view downloads, and I'm going to select, and what I'm going to do actually, let's do something a little bit different, because you could just click it and open it and always launch it from your downloads directory. But I prefer to do something a little bit different here. Let's go into Windows Explorer first. All right, and I'm going to go to the downloads directory. I got a lot of junk in here. Let's find Bob's first demo RDP, and I'm going to drag and drop that to the desktop. So let me rearrange some things here, pull that there, and drop it. Great. Okay, now what I'm going to do is right-click and select Edit. And here I'm going to get to change some of the settings, and this will really help from this point on. For example, I can give it the username and have it save that. And I can also choose the display size, and I'm going to need that to be much smaller than the default. So 1280 by 720 would be good. And local resources, I can set up, whether I want to connect my audio and things of that nature to it. But I think that's all I need. And so let's save that and close this. Now let's double click it and open it up again. And it wants to just make sure that we're okay with launching a file that originally came from the internet. I'm going to go ahead and click OK. Now it knows me as Tabaro, and I just have to type in my password at this point. And I can even click remember my credentials, so I don't even type that in again. Finally, it's going to ask if I'm okay with the fact that the certificate is not from a trusting certifying authority. I'm going to go ahead and click don't ask me that again for connections to this computer, and click yes. All right, and you can see we're trying to connect. It's setting up the user for the first use. Yeah, you can see things are slowly coming online here. Let's go ahead and click no to that. It's popping open Server Manager. So if you're familiar with Windows Server 2012, this will look familiar to you. It's how you, it's kind of like a start page to set up your server and give the various services that you'll need in an easy way. But you can always just go back here and go to the typical, usage. The typical way of administrating a server. So I think that's pretty much all we need to do for now. In the next module, we're going to go a little bit beyond this and start setting up endpoints so that we can access our server using different services. Like, for example, SQL Server Management Studio in order to remotely manage a virtual machine that hosts SQL Server. That's a common scenario. Okay, so we'll see you in that module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In a previous module, we set up a new virtual machine and then we connected to it using Remote Desktop Protocol. And now I want to show you how to set up network endpoints so that other applications or other users can connect to that virtual machine as well using different tools and different ports. So I'm going to demonstrate in this module a common scenario. As you can see on screen right now, I've already created a new virtual machine that hosts SQL Server. I'll show you how I did that in just a moment. And then what I want to do is ultimately add a new network endpoint here to port 1433 because that's the port that SQL Server Management Studio needs to connect remotely to a remote SQL Server instance. And then I'll finally open up SQL Server Management Studio on my local box and I'll try to remote in via SSMS and create a database and create a table and so on. All right. So I already have that ready, but before we do that, what I want to do is go back to this notion of creating a virtual machine. In the previous module, I showed you how to create a virtual machine using Quick Create, and that was fine for just setting some of the basic properties and immediately creating a new virtual machine without really worrying about any of the other considerations that we listed. For example, availability set, is it going to be part of a virtual network? Where do you want to put it in storage account, things of that nature. So what I want to do this time is actually create a virtual machine from the gallery and be able to choose a lot of those options right up front, including we can set up endpoints to be configured immediately as it's provisioning the new virtual machine. So let's go ahead and choose from gallery this time. I chose a SQL Server image, and specifically I chose one of the less feature-rich versions, just SQL Server 2014 RTM Web. It has fewer features and less horsepower, I think, than standard and enterprise. I'm not completely up to date on exactly what the differences are, but at any rate, I know that it would suit my needs for a particular application. Let's go ahead and click the next on the wizard, and I'm going to give it a name, my latest SQL box. Hopefully that'll fit. I can choose standard or basic tier. I can choose the size just like I could previously. Now I'm going to need to give it a username for the box to log into it and a password. And go on to the next step of the wizard. And here we have some more options that we can configure. For example, do we want this virtual machine to be deployed into an existing cloud service or into a new cloud service? Now, I haven't talked about cloud services. I said we don't need to know cloud services. Let's not talk about cloud services. I'm going to ignore cloud services for the last 3 courses in this series. However, virtual machines and cloud services have this interesting connection, this interesting history. And in order to really understand how to configure virtual machines and virtual networks correctly, we can't help but get into cloud services just a tiny bit. I don't want to talk about it right now, but we're going to go ahead and leave it at the default option to create a new cloud service just the way it is. I'm going to choose a region, or I could choose an affinity group that I've already got created. I'm not going to do that here. East US. Now I could choose an existing storage account. Remember, we can let Azure create a brand new storage account, but it's going to create some long, complicated name that really doesn't have any meaning inside of our Azure account. So we could create a new storage account first, and then put the virtual hard drives inside of that storage account. I'm not going to do that here. I'm going to let it go ahead and automatically generate a new storage account for us. Also, we talked about availability sets in the previous module, and I said we could create a new availability set for uptime purposes, so that if one of our virtual machines goes down, all the traffic gets routed to just the other or several other machines in an availability set. We're going to spend a whole module talking about availability sets. We could assign an availability set right here, or we can create a new availability set right here, but I'm not going to do either. I'm just going to leave the default option none selected. Now, I said all of that to say this. I can go ahead and set up endpoints right here in this fourth step of the Create New Virtual Machine wizard. And for example, I can go ahead and select one of the known protocols and ports. For example, if I want to choose to open up HTTP and HTTPS on 80 and 443, I can do that right here. I can open up FTP on 20 and 21. Or in our case, I could select MS SQL, and you see that it opens up port 1433 for us, or it enables that endpoint, I should say. And then I could click the next button to go ahead and create a new virtual machine. I don't want to do that. So let's go ahead and back out of this. Actually, I'll just minimize that. But what I want to do is I want to look at how to go ahead and configure an endpoint for an existing virtual machine that I have. Say, for example, I didn't think ahead of time that I needed SQL Server and I installed it after the fact, or I just wanted to take control of that process in a more granular fashion. Well, in that case, what we can do is come back here to our virtual machines. Here's our list of virtual machines, and here's Bob's SQL machine that I just created and that you saw on screen a moment ago. Then I'm going to go to Endpoints tab at the very top, and I'm going to click Add an Endpoint. Now I can create a standalone endpoint, or I can create an endpoint to an existing load balance set. We'll talk about load balancing, the two options in Azure Load Balancer and the internal load balancer, and we'll talk about load balance sets as well in an upcoming module. But for right now, I'm just going to add a standalone endpoint. And click Next. Here I want to choose a name for the endpoint. This is just for my own reference so that when I look, I see, oh yeah, okay, I see that was for that 1443 that I opened up. That was for SQL Server. So I can just, here again, choose that similar drop-down list box, choose MS SQL. Notice that it goes ahead and fills in the protocol, public port, private port for me. I can go ahead and create a load balance set right from here. I'm just going to go ahead and leave all these options and click OK. And now it's updating the Azure Load Balancer, which we'll talk about later, and it's going to map that port on the IP address for Bob's SQL machine to the endpoint and private port on my virtual machine. So you can see that that's in progress. You can see the little progress bar down here. Okay, and so the endpoint is opened up. We should be good to go, right? So I'm going to go ahead and launch SQL Server Management Studio on my local computer. And let's go ahead and give it the name. I forgot the name of it already. Bob's SQL Machine. I think that's what I called it. Let me check real quick here. Bob's SQL Machine .cloudapp.net, and I'll give it the login to borrow, and I'll make sure SQL Server authentication is enabled, and I'll go ahead and click connect, and you'll notice that in a second it will not allow us to do this. All right, it took about a minute, but it basically says that there was an error while establishing a connection to SQL Server. Server was not found or not accessible. All right, so really what the problem is that we have not created any users that would allow us to log in using SQL Server authentication. So at this point, we can connect in a sense, to the machine, but we try to get into SQL Server and it says, I don't know who you are, I'm not going to let you in. So let's go ahead and cancel this and go the last mile with this example. And let's go ahead and close that out and open up SQL Server Management Studio here on the client, or rather on the virtual machine. So again, the endpoint's been created and the port is open. However, what we need to do is to, first of all, I was too hasty in shutting down Server Manager. What I actually need to do is to allow traffic on 1433 through the firewall. So that's the first step that we're going to take. So we'll go to Tools, Windows Firewall and Advanced Security. We'll go to Inbound Rules, and we're going to create a new rule. And we're going to do it on a specific port, and then I'm going to select Next. And it's going to be for TCP for port 1433. And click Next. And we're going to select Allow the Connection. And I'll go ahead and leave these rules selected, but you may want to change these to further increase your level of security on the server. And I'm going to call this MS SQL and click Finish. All right, so that's step number one. Now that we've created a rule for our firewall, we should be able to go, close that down, and get back into SQL Server Management Studio. At this point, I want to make sure that I have the correct setting in SQL Server so that it allows connections through TCP/IP instead of just name pipes. So I'm going to go to SQL Server Configuration Manager. It's the red icon. And what I want to do is drill down SQL Server Network Configuration, Protocols for MS SQL Server, and TCP/IP should be enabled. If it's not, make sure it's enabled by double-clicking it and changing it here on this dialog. Okay, so now that we've made sure that we can indeed accept connections through TCP/IP on port 1433, and the firewall is not going to block it, now the next thing that we're going to need to do is go into SQL Server Management Studio. I'm going to right-click Bob SQL Machine here in the top of the Object Explorer and select Properties. On the Security tab, I'm going to select that I want to create a new SQL Server and Windows Authentication mode, so mixed mode, and I'm going to click OK. And it says that it needs to reboot SQL Server so that these changes can be made. So I'm going to right-click and select Restart. And yes, I want to restart SQL Server. Okay, so hopefully it's back online now. And the next thing I want to do is go to the Security tab, drill down to Logins, and we're going to create a new login. Just right-click and select New Login. And let's create a login named Bob, and it'll be SQL Server Authentication, so I'm going to create a new password. And I'm going to deselect enforced password expiration and a lot of that stuff. I really don't need it. What I do want to do is go to the server roles, and I want to add DB Creator. And I'm going to click OK. All right, now I should be able to open SQL Server Management Studio locally here, if I did everything right. And let's go to Bob's SQL Machine, and we'll log in with the username Bob and type in the password, click Connect. All right, and let me go ahead and resize this window so you can see it. All right, and you can see that we are in. So I can go here to Databases, and what I want to do is create a new database, and we'll just call this Customers, and click OK. Now I might want to change where these are saved. I may not want them on the C drive. I won't want them on the D drive, and I might want to put the SQL database on a virtual hard drive that we add, that we connect to the virtual machine, which we'll demonstrate how to do later. All right, so customers, let's go ahead and create a new table. Let's drill in and right-click tables and click New Table. And we'll call this, I don't know, Salesman ID. Make it int. And let me resize one more time. All right, and I want to make this Just an identity, yes. And I want to make this a key. And then I'll put salesman name and just make that an N bar char, 30 or something like that. Yeah, 50 is fine. And no nulls. And I should be able to now save that. And we're going to call this salesman. Click OK. And let's go ahead and just even add edit the top 200 rows. And I'll put Bob Tabor here. And that should have created a new row in the database. So let me go ahead and close down my local. And now let me go to databases here out on the virtual machine up in Azure. And I'll go ahead and select refresh. You can see it sees the customer's database, sees the salesman table. If I right click and select edit the top 200 rows, it's going to show me Bob Tabor with an ID of 1, hopefully. And it does. Awesome. Okay, so you can see pretty much the process. First of all, I had to add an endpoint, and then on the machine I may have some extra configuration to do. In my case, I had to open up a firewall, make a firewall rule for it, and then tell SQL Server that we're going to create a new user. So a lot of this was superfluous to really the purpose of this module, which was to show you how to create an endpoint. But I thought that this case was so common that you probably want to see all the steps involved. All right, so we're going to keep moving on in the next module. We'll see you there. Thanks. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to demonstrate how to attach a new empty disk or virtual hard drive to my virtual machine. Now you can see that I'm using Bob's first demo, the virtual machine that we created 2 modules ago. And what I want to do is attach a new empty disk to this. So it's pretty easy to do. Honestly, we're going to go back to the portal and we're going to go to and select one of the virtual machines in my list. I can also drill in and do it from there as well. But let's just go ahead and we have Bob's first demo selected. I'm just going to select attach an empty disk. It's going to ask me for some information about this empty disk. I might rename it. That's probably one of the things I really want to do. My first empty disk. It's a pretty bad name, but hopefully you get the idea. We'll make it a 5 gig disk. We'll make it read-write. And we can choose where we want to put it. It's going to, by default, put it in this storage account under the /VHDs subdirectory. So that looks good. I'm going to go ahead and click OK. And it will take a minute or two to set that up. Okay, and it literally took about 90 seconds to do this. So let's take a look now at the disks, the list of disks. And you see it just popped up here, and it's difficult to kind of to see it. What you can do, first of all, there are operating system disks, and you can see what virtual machine they're attached to. So this would logically be it. Let's go ahead and just pull the location over a little bit so we can see. And here you have the location as my storage account /VHDS / my first empty disk.vhd. Okay, so we're good to go there. The next thing we would need to do is to come in here and to initialize it and format it, which we'll do in the next module. But before we leave this topic, I want to talk about attaching an existing disk. So let's say, for example, let's go back over here to this list. I created another virtual hard drive called bobsdisk.vhd. And I attached that to Bob's SQL machine that I created in the previous module. Now, what if I wanted to attach that hard drive to Bob's first demo? In other words, to this virtual machine? I can do that. I certainly can do that. What I have to do, however, is what is prescribed on this page, which is to run this add-Azure VHD commandlet. And what it will do is it will prepare that virtual hard drive for use as a disk that we can mount to from a different from a different virtual machine. I'm not going to demonstrate how to do that in this module, but it pretty much walks you through the steps of doing that. And if you have any questions about how to use the add Azure VHD commandlet, just take a look at that link, and it will give you some sample PowerShell commands to run. Okay, so this is half of the equation. We'll pick this back up in the next module where we'll actually now initialize and format it for use. So we'll see you there. Thanks. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to demonstrate how to format a new empty virtual hard drive in a Windows Server virtual machine. Now, honestly, there's no secret here. If you've worked with Windows Server, or if you've even worked with Windows 8 and you have added a physical hard drive to your computer, you use the same technique as if you were initializing and formatting it a new physical hard drive in your computer. So what we're going to do is come over here. We know from the Azure portal that we've attached a new empty disk. It was 5 gigs and we gave it a name. So we know it's there. We just have to now attach to it. So what I'm going to do is right click over here in the lower right hand corner and select Disk Management. And if we did everything correctly in the previous module, we should see a new uninitialized disk. You can see it here at the very bottom. Let me see if I can, well, I'm not sure I can scroll down there because of this window. In fact, let me just go ahead and cancel this for now. And so we can scroll down and look at this disk 2. It's unknown, it's only 5 gig, and it's unallocated. And so it's initialized the disk. The next thing we've got to do is create a partition and then format that partition. So I'm going to right click and select New Simple Volume. And it pops open the New Simple Volume wizard. I can say, oh, I only want like 2500 or 2.5 gigs for use in this particular drive. But in our case, I'm just going to go ahead and give it everything we've got. So let's go ahead and click Next. We can assign a drive letter. It doesn't start with the letter E, unfortunately. It goes straight to F, G, H. So we're going to choose F as the drive letter and click Next. And then we can choose the file system, NTFS, probably what you should choose. The allocation unit size, unless you have a reason otherwise to do it, choose default, and then give it a volume name like a Bob's Data Disk or something like that so you can recognize it. And we're going to perform a quick format on it, but we're not going to enable file and folder compression. That will slow things down just a little bit. So let's click Next. Everything looks great. Click Finished. Takes less than a minute. And now we have a drive, a new drive. You can see that as I open up Windows Explorer that it too wanted me to know that there's a new drive that I can format, the F drive, before I can use it. Now I've already done that, so I'll click Cancel. What I do want to do, however, is just to prove that it's available on my system. You can see it's here in Windows Explorer. It's 4.96 gigs, free 4.99 gigs. So that's great. That's exactly what we wanted. And that's really all there is to it. We won't draw this out. We'll see you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to create an image, a reusable image, from the existing configuration in a virtual machine. So, to start off with, I have a virtual machine that I've already set up and I've been working with for a few minutes here. You can see it's called Bob's Image. Let's take a look at it, its configuration inside of the portal. If you go to the dashboard, you can see, first of all, I am using an A4 with 8 cores and 16 gigs of memory. And I believe, oh yeah, you can see the disks that are associated with it. There's a 2 gig disk and a 5 gig disk called Bob's Image 1 and Bob's Image 2. And we could drill into that a little bit more. If you take a look at the Configure tab, you can see that it is not in an availability set. However, it is set up to have an endpoint for MS SQL, so at port 1433. Okay, so let's then go into the machine itself. copy the RDP file onto my desktop, and I'm connected into that machine right here. And what my objective is to set up the machine and then create an image and see what do we get that gets copied over from the image, so that the next time we create a hard drive, a virtual machine off of that image, what comes along and what doesn't. So I created an image using the virtual machine for SQL Server Web Edition. So if you pop open SQL Server Management Studio and connect to it, you can see that I've already set up a database called My Database. It has one table called My Table, and it has, let's see, just 2 rows of data, I believe. Select, edit. So I just have 2 little nonsensical little phrases in there. Now, the more important thing is where I actually stored the data files for that database. So if we go to and look at, you remember we have 2 drives that have been attached to this virtual machine, the F volume, which is 2 gigs, and the G volume, which is 5 gigs. In the G volume, I created a data folder, and that's where my database and the log files are stored. So let's take a look then at the F, and what I did in all of the hard drives, or at least the C and the F, I added a little file, a text file, and I just put some text in there. And I did the same thing for the C drive and put a C file.txt. And I also created one on the desktop called desktop file, and this is just a little extra text here. And again, I want to see what gets copied over into the newly created image and what doesn't. Will SQL Server make it? Will the database that I create make it? Will these files make it into the image? Okay, so that's my little experiment here. And to get started, what I'm going to do is actually open up the command prompt, and I'm going to navigate into the Windows directory, into the System32 directory, and I think there's sysprep is the directory. Yeah, and then I'm just going to run sysprep. And when I do that, it's going to launch the system preparation tool, and it's going to first of all perform a cleanup on our virtual machine. And I'm going to go ahead and select the generalize checkbox here. And then it's going to shut down the virtual machine. I'm actually going to say go ahead and shut it down. And I'm going to kick that off, and that's going to take several minutes, but it's preparing the hard drive to, or the virtual machine to be used as an image. So at this point, I'm going to go ahead and pause the recording of the video because this is going to take a little bit of time. It will disconnect me from the remote desktop connection, and then the next time I see it will be in the portal. So let's go ahead and just pause right here. Okay, it's been about, I don't know, 10 or 15 minutes or so. I walked away from the computer, honestly. And it seems like the system preparation tool did its work. It shut down the virtual machine, and now we're here. So the next step in the process is to click the capture button, and this allows us to give the image a name, probably something a little more friendly than that. Let's just call it Bob's image. Hopefully that'll work. And then we'll say SQL Server and more. And I'm going to click the little check mark next to I have run sysprep on the virtual machine. Great. And it says that the virtual machine will be deleted after the image is captured. So this is it. You're converting this over, and it's no longer going to be available as a virtual machine. It's only going to be available as an image from this point on. So I'm cool with that. I'm going to go ahead and click complete. And now this will take a few minutes as well. Okay, and after a few more minutes, it looks like that if we go to the instances, our virtual machine is gone. However, it does show up now in our images. Great. Okay, so the next thing is to go ahead and try to create a new virtual machine based on that image. So we'll go to Compute Virtual Machine from Gallery. We're going to choose a image from My Images, and you can see we have a Bob's image here. I can see something promising here that it has 3 disks. But other than that, I don't have many more details. Now, as I go through this, I'm going to give it a name. So Bob's VM, let's call it Bob's VM. Let's see if that works. And then notice that it did not retain the size of the, it didn't retain the machine type. I'm going to have to reselect A4 or give it a different, let's see what happens when I give it A2. Yeah, okay, let's do that. And then we're gonna have to give it a new username. And click next. Here we have to choose a cloud service, so that didn't come over. And I'm not going to give it an availability set, and notice that it doesn't retain the endpoint. So I'm going to have to choose that all over again if in fact I want it, not MySQL, I want MS SQL. There we go. Let's get rid of that. Okay, let's go next. And let's hit complete, and now let's watch the fireworks. Okay, through the magic of editing, it's taken about 10 minutes, but we're back here in the portal. It looks like it's finished creating Bob's VM. I have already clicked the connect button, downloaded the RDP file. I've already dragged it to my desktop. I've already edited it. And now I'm going to double click it for the first time and log in. Okay, and things are slowly coming online. Let's click no to that. Let's open up. Now, you notice that we don't have our desktop file, and we don't have our, I added some links from tools to the toolbar, and I don't have those, but I do have an E drive and an F drive. So formerly was the F drive. Let's open this up, and you can see that, so it mounted the drives a little bit differently. Here is my F file on the E drive, so that's interesting. And let's see what happened with our database server. Now it's on the F drive, and when we go to launch SQL Server Management Studio, I'm willing to bet things are going to be a little confused. So let's find SQL Server Management Studio. There you are. Let's go ahead and pin you out to the taskbar. Back here and open you up. And while that's launching, let's take a look at the C drive, see if we can find our C file. Our C file is still there, okay? So that's the contents of our drives are here. Unfortunately, the mounting of the letters of the drives are a little bit off. I think we can fix that though. All right, and finally it came up. I'm going to click connect. All right, now let's see if we can find databases. And it says something with regards to a recovery pending. So some challenges, but almost everything is set up correctly, and we can go from there with it. So still pretty cool. All right, so that's all I really wanted to demonstrate. Our little experiment was partially successful. It was very interesting and informative, but let's move on. We'll see you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to talk about availability sets and how they help to ensure that your app is up and running during a maintenance event. So before we get into the specifics of availability sets, let's talk about maintenance events with regards to Azure. Now, there are planned maintenance events and unplanned maintenance events. So a planned maintenance event, this is when Microsoft occasionally updates the underlying Azure platform for a number of different reasons, to improve the overall reliability of the platform, to improve performance, to improve security, and so on. The majority of these updates are performed without any impact on your virtual machines or your cloud services. However, there are instances where these updates require a reboot of your virtual machine to apply the required updates to the platform infrastructure. But they're planned, they're known ahead of time. There's also unplanned maintenance events. And so these occur whenever the hardware or the physical infrastructure that hosts your virtual machine has failed. So these are things like a local network failure or a local disk failure or other rack level failures with the physical hardware itself. So whenever a failure like this is detected, the Azure platform will automatically take your virtual machines and migrate them from the unhealthy physical hardware that are hosting your virtual machines to a healthy set of physical compute resources. All right, so this doesn't happen very often, but it does happen occasionally, so it might also cause your virtual machine to reboot. But in either case, if your application is running a single instance on a single virtual machine, if there's only one application server running on one virtual machine, then maintenance events like these could mean downtime for your application. However, you can add one or more virtual machines to also run your application, and then you add them both to what's called an availability set. Now, if one application server is no longer accessible, then the Azure Load Balancer will route all incoming requests to the other servers in the availability set. Now, obviously, if you only have one virtual machine in an availability set, you might as well not even have an availability set. It just doesn't make sense. It's not a set, it's just one. It only makes sense to have two or more virtual machines in an availability set. And so when you add two virtual machines in an availability set, Microsoft then gives you a service level agreement for uptime. I believe it's 99.95, meaning that there's a certain amount of tolerable downtime each month. I'm not sure what 0.95 is. It's like maybe a few minutes per month. But more than that, Microsoft will then refund you based on the length of the outage and downtime. Also, I hope it's obvious that when we say that you should add two or more virtual machines to an availability set, those virtual machines should serve the same purpose in the application's architecture. So they should be configured in such a way that a request that's made to the application layer on one virtual machine wouldn't be different from the same request were it to be routed to a different virtual machine that hosts that same application layer. In other words, suppose you have two applications that are in use in your company. Each has a very simple three-tier architecture. You have a presentation tier, which might be web servers. You have a middle tier, which might be some business rules that are hosted in a web API layer. And then you have a data tier, and that would be something like SQL Server database running in the back end. So you'd want to create, in that case, you have two applications, each with three tiers. You want to create 6 availability sets for maximum fault tolerance. So for application A, you would have an availability group containing 2 or more virtual machines as web servers in the presentation tier to ensure that the web servers are always taking requests. You would have another availability group containing 2 or more servers in the middle tier to ensure that they're always responding to requests from the presentation tier. And finally, you would have another availability group with 2 or more virtual machines in the data tier responding to requests for data. Then you would have the same number of availability sets for your other application, application B, application A, application B, 6 availability sets, okay? Hopefully that helps makes it a little bit clearer. And before we move on, I just want to give you a small peek under the hood about how availability sets, how they work, how they help you out. I'm not sure this is anything you can actually configure. It's interesting just to see how they carefully work around planned and unplanned maintenance events. So each virtual machine in your availability set is assigned an update domain and a fault domain by the underlying Azure platform. So update domains and fault domains. Update domains are used to decide the order in which the virtual machines in an availability set are rebooted and updated during a planned maintenance event. So there are up to 5 update domains that will be that your virtual machines will be assigned to. So if you have 7 virtual machines, you'll have virtual machine 1 in update domain 1, virtual machine 2 in update domain 2, virtual machine 3 in update domain 3, virtual machine 4 in update 4, 5 and 5. Then the 6th one will be assigned back to update domain 1, and the 7th one will be assigned to update 5. Hopefully that makes sense. And again, this has to do with the rolling nature of the updates and the reboots of those virtual machines inside of an availability set. And so if you have, again, multiple servers inside or virtual machines inside an availability set, they're going to be guaranteed to be on at least 5 different physical hardware clusters so that all the virtual machines are not affected at once whenever there needs to be an update and there needs to be a maintenance event. Likewise, a fault domain ensures that all of the virtual machines in an availability set are not sitting on the same physical hardware in order to reduce the impact of potential physical hardware failures, network outages, or power interruptions. It's the same idea. Make sure they're not all sitting on the same hardware so that if something goes bad, then at least the virtual machines will be sitting in the same tier on different physical servers. Okay, so that's all that I want to say conceptually about availability sets. There are actually 2 different ways to set up an availability set. Suppose you have an existing virtual machine, such as Bob's second image that we created a little bit earlier. And you can go to the Configure tab, and you can change from no availability set to create an availability set, and we'll call this first availability set. Let's see if it takes that. That's a little bit too long. Okay, let's call first set. And it should take that and save that. All right, so that's one way. So you'd go in and you would assign each of your virtual machines to that first set. Save that, yes. Okay, and so while that's updating, let's show you the other way. You can actually, and we've seen this before, you can add new virtual machines to a availability set by going through the compute virtual machine from gallery, where you can choose an image. Let's just choose a Windows Server 2012 R2 data center, and we'll fill in some of this. Maybe just call this Bob's third VM. Give it 2 cores. Username doesn't really matter. All right, here you can see that we get to choose an availability set. We can create a new availability set, or we can select from an existing one. You'll notice that our existing availability set's not in the list just yet. I think it's just not done updating from our previous update just a moment ago. But those are the 2 ways that you would add virtual machines to an availability set. All right, so in closing, one more point. You should combine availability sets with the Azure Load Balancer to get the most application resiliency. The Azure Load Balancer distributes traffic between multiple virtual machines. We're going to talk about load balancing in the very next module. But specifically in regards to availability sets, if the load balancer is not configured to balance traffic across multiple virtual machines, then any planned maintenance event will affect the only traffic serving virtual machine, causing an outage to your application tier, obviously. So placing multiple virtual machines on the same tier under the same load balancer and the same availability set enables traffic to be continuously served by at least one instance of a VM that serves up a given application tier. Okay? Hopefully that makes sense. So that's where we're going to actually pick it up in the very next module as we talk about load balancing. See you there. Thanks. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about load balancing in general, then more specifically, the Azure Load Balancer, and then the internal load balancer. So let's start in general terms. What is a load balancer? Well, the goal of a load balancer is to spread requests across 2 or more servers so that incoming requests don't pile up and the response time doesn't increase. So there are many different algorithms that can be used to distribute traffic in between 2 or more servers that are hosting essentially the same application or the same service, whether it be for a website or for a web API or a database or whatever the case might be. And there are different algorithms used by different vendors, but Azure uses a simple random distribution of traffic to virtual machines. Now, this random distribution of traffic won't necessarily distribute the load evenly, because it could randomly distribute some requests that are more processor intensive by chance to a single server in the grouping of servers that are available, but over time it probably would all equal out. So to accomplish this distribution, a load balancer will distribute traffic between multiple servers that host the same resource. Again, 2 or more virtual machines that serve up one of the tiers of an application. Web servers, middle tier servers, web API servers, database servers, that sort of thing. Now, more specifically, with regards to the Azure load balancer, you would distribute traffic to different virtual machines inside the same load balanced set. Now, a load balanced set is a set of 2 or more machines, virtual machines, that the Azure load balancer will distribute traffic to randomly. Now, you might say, well, that sounds a lot like availability sets, and you'd be partially right. The intent is different, but the idea is similar. In an availability set, you're grouping virtual machines in order to protect against downtime due to planned or unplanned maintenance events. So if a planned maintenance event happens, then there might be some rebooting of servers to take advantage of updates, but it won't reboot all of the servers at the same time. So the traffic would be distributed to those that are up and running, and waiting for the other one to come back online. So that's availability sets. But in a load balance set, you're grouping virtual machines to improve resiliency and hopefully to improve response time. So again, the intent is different between availability sets and load balance sets. Now, honestly, I think you're going to probably wind up creating load balance sets of internal load balance sets along your availability set boundaries. In other words, you would have perhaps 3 servers in an availability set. You're probably going to have those same 3 servers in a load balance set. Maybe not. I'm no expert, but it seems like they're 2 sides of the same coin. You probably want to group them together for both purposes. All right, so a moment ago I said that traffic is distributed randomly, but it can also actually be configured to something called source IP affinity, or in other words, stickiness. So a given client, once it's been handled by one virtual machine, any future requests made by that client would be routed back to that same virtual machine. And so if there was some state that needed to be saved, some session state in memory, it could always be routed back from that particular client back to that same web server hosted on a virtual machine. And while that's possible, designing applications around this is probably not a good idea in my opinion. Any state or session state or whatever the case might be that's required by an application should be saved to some neutral storage area so that any instance of that application service, any virtual machine hosting Internet Information Services, for example, would be able to handle any incoming request. But that's just my opinion, and I'm digressing, so let's move on. Let's talk about the 3 different ways that we have that load balancing happens in Microsoft Azure. So there is load balancing at the DNS level using Traffic Manager. Now, we've already used Traffic Manager in the course entitled Websites, and we saw how it worked. We had a website in Western Europe and a website, the same website hosted in a website in the East US. Then we sent a request from somewhere in the United States, and we were served up the East US version. Then we logged into a virtual machine over in Europe, and we requested the same web page, but we were routed to the Western Europe version of the website. So the Traffic Manager looked at the incoming request, and it used some DNS trickery to push that incoming request to the geographically closest host for that website request. So that again is load balancing at the DNS level using Traffic Manager. We're not going to go into it anymore in this series because we've already looked into it. But there's also load balancing at the network level via the Azure Load Balancer. And so the Azure Load Balancer distributes traffic from outside of Azure to virtual machines inside of Azure. And so in this scenario, we might have a series of virtual machines that serve up a website. They all are hosting Internet Information Services. They're all hosting the same code base. And so as incoming requests come into the load balancer, it will distribute that load across the various virtual machines. And then finally, there's network level load balancing via an internal load balancer. And so This is similar to the Azure Load Balancer, but it's actually a different mechanism. It distributes requests that come from inside of Azure between virtual machines that are also inside of Azure, or between cloud services in the same virtual network with VMs in the same cloud service that are also part of that virtual network. Again, that's kind of an advanced case. But at any rate, let's maybe look at a few examples. If you see in this first slide, here is a very simple case where a request for a website comes in over port 80, and the Azure Load Balancer handles it and it passes it on to one of several virtual machines that are configured with the same code base. All right, and so this again is great for distributing load and making sure that one virtual machine is not handling all the requests, and therefore hopefully speeding up and making everything a little bit more snappy because nobody has to handle the full load, the full brunt of incoming requests. Now in the second scenario, things get a little bit more interesting. Here we have a request that comes over SSL, so port 443. And you can see that it gets routed to one of three virtual machines here that are called the web tier. And then because that particular code base requires some access to SQL Server, it makes a request over port 1433 to an internal load balancer, which distributes that request to a virtual machine that's hosting SQL Server, the database tier there at the bottom, so that any incoming request won't block other incoming requests that can just be pushed randomly to the various virtual machines that also host SQL Server and are serving up that same data. All right, so here's just a variation on this idea where we have an on-premise network that's connecting through a VPN connection into a virtual network, and you can see this little kind of angle bracket ... boundary. That just means it's a virtual network. And then inside of that, there's another boundary .. around the line of business servers with a little cloud with two gears in it. That's called the cloud service boundary. We'll talk about cloud services and how they relate to virtual machines soon. But at any rate, you can see a request comes in from a client that's on an on-premise network, and through the magic of VPN comes into a virtual network. And that traffic gets routed not to the Azure Load Balancer, but rather to the internal load balancer, which distributes the request to those virtual machines that are internal in Azure. All right, and then this final scenario is even more advanced. It's pretty much the same. It's a combination of the two that we've already looked at, where connections can either come from a client on premise or from somebody out on the internet. But either way, the requests are going to be routed either through the load balancer if they're coming in for a web request, or system administrators sitting inside of a company may want to administer the SQL Server, so they would hit it through SQL Server Management Studio, which gets routed into the internal load balancer and passed to one of the instances that virtual machines that are handling requests, handling SQL Server requests. Okay. In the next module, we'll take a moment and we'll examine how to actually set up a load balance set, and we'll talk about how you do it for both just the Azure Load Balancer as well as the internal load balancer. But I think from a conceptual perspective, we've talked about everything we need to in this module. So hopefully you can see the important role that the load balancers play in accepting traffic, whether from the internet or from other virtual machines inside of the Azure Data Center, and routing it to the appropriate virtual machine, a healthy virtual machine, to improve the resiliency of the applications that reside on those virtual machines. We also talked about creating load balance sets and more. So that pretty much wraps up what we wanted to say conceptually about load balancing in Azure. Let's see how we set it up, how we create a load balance set in Azure in the very next lesson. We'll see you there. Thanks. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to talk about creating a load balance set. So configuring an existing virtual machine to be part of a load balance set. And then we'll also talk about the steps required to, briefly to create an internal load balance set as well, but we're not going to demonstrate it. Okay, so for a given virtual machine, so I have Bob's second image here. Let's go ahead and look at the endpoints tab, and we're going to create a new endpoint. Now, why are we creating a new endpoint? Because traffic that's going to be load balanced will typically be sent over one port, whether it's port 80, port 443, port 2021 for FTP, I don't know, 1433 again for SQL Server, all those common ports that you might want to load balance. So it has to do with an endpoint. So we're going to create a new endpoint, and part of the endpoint process will be adding to an existing load balance set, if there was one, but there's not. So we're just going to add a standalone endpoint at this time, but on the next step of that wizard, we're going to be able to, for example, let's just create it for HTTP, and we can choose the protocol, the public port, the private port, and then say I want to create a load balance set. Now when I do that, notice that a new step was added to the wizard. Step 3 has been added here. So let's go ahead to step number 3 and give this load balance set a name. You can see that I have a couple here already, but I'm going to call this my load balance set. And here again, I can give it a probe protocol, a probe port, and a probe interval in seconds, and the number of probes. So basically, this has to do with the load balancer's relationship with the actual virtual machine, and how often should it try and see if that virtual machine is still healthy and accepting connections. So in this particular case, every 15 seconds it's going to probe port 80, and it's going to probe it twice. And if it can't connect on 2 consecutive times, then it's going to consider that particular virtual machine that there's something wrong with it, and it will route traffic away from it. It won't give it any new incoming requests. All right, and that's pretty much how you create a new load balance set. Now, in this case, if we wanted to create, use another virtual machine and add it to that same set, we would just go through that same process where we click Add, and then we want to add to an existing load balance set. But that, in a nutshell, is how you would create the load balance set and then add your virtual machines to that load balance set. Now, we said that you can also create an internal load balance set. However, unfortunately, it's going to require us to use some PowerShell, and I'm not going to demonstrate how to do that, but I would recommend, if you're interested in how to configure an internal load balance set, that you follow the instructions in this document on MSDN. Okay, so those are the specifics of how to work with the things that we talked about up to this point. Let's move on. See you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. We've been talking about the load balancer and how it routes traffic from the internet to a virtual machine, and then how traffic is load balanced inside of Azure. So in this module, I want to add one more kind of related item to this. I want to talk about virtual and reserved IP addresses for use in Azure virtual machines. Now, way back in the second module of this course, I said that whenever you provision a new virtual machine, it's going to be provisioned with several things, not the least of which is 2 IP addresses. There is going to be a public virtual IP address and then a private IP address. Let's talk about the public virtual IP address first. This IP address can be used to access resources on the virtual machine from outside of Azure, so on the internet at large. So, for example, if you're hosting Internet Information Services inside of a virtual machine and you want to open up HTTP, so you want to serve up websites through IIS on the virtual machine, you're going to get a virtual IP address. It's going to be unique to you. You can use it for as long as you keep that virtual machine up and running. And you can even use a DNS record to map www.whatever.com to that virtual machine. And the Azure Load Balancer will send that request right to that virtual machine, and life is good. So the second IP address that's provisioned to a virtual machine whenever you create one is for internal communication inside of Azure only. So this is used by the Azure Load Balancer to route requests in a load balancing scenario, and it's also used by virtual machines inside of a virtual network to communicate directly with each other. Now, the problem with both of these IP addresses is that they're not sticky to your subscription. So, for example, you may want to automate the standing up and the shutting down of virtual machines using a PowerShell script. You have the need for different virtual machines at different application tiers to know about each other. Your web tier needs to know the IP address where your web API or your database is. So there's got to be some relationship there, and you can configure that usually with a configuration file or something on the website. But the next time you stand up the virtual machine, it'll have a different virtual IP address and a different private IP address. So in this scenario, you would need to update the public internet DNS service to point to the new virtual IP address, as well as any internal communication that has to happen. You'd have to update the configuration file that points from the web server to the database as well. So obviously this is less than ideal. Now the good news is that you can replace the virtual IP address with a reserved IP address, which is permanently associated with your subscription for any cloud services and virtual machines inside of a given region. In fact, you can create up to 5 reserved IP addresses per subscription, and you can ask for more if you need them. Now, the bad news, at least for me, is that in order to do this at the time that I'm recording this module, the only way to do this is through PowerShell or through the RESTful HTTP API. So I'm not going to demonstrate how to do this. However, you're going to need to have Azure PowerShell installed, and then you can follow the instructions that you see on this web page, bit.do/reserved IP addresses. So similarly, you can replace the private internal IP address with a static IP address. This accomplishes basically the same thing that we just discussed, but simply for the IP address that you'll use for private traffic inside of Azure. And this is available only for virtual machines, again, that are inside of virtual networks. So it's only available for machines that are available inside of, that are configured to be inside of a virtual network. And I'm going to talk about virtual networks soon. I've been promising it for a while. We'll get to it. But basically, a virtual network is what it sounds like, a network comprised of virtual machines inside of Azure, which is a gross oversimplification. Again, we'll come back to that soon. All right, so take a look at this URL on screen. This web page explains the idea further, and it points to step-by-step instructions on how to set this all up yourself. Now, as that web page notes, you may want a static IP address when you need to rely on an IP address and you don't want to worry about losing that IP address because it would be painful to have to update, again, that configuration file, or it would be painful to, that web page gives a specific case. The author mentions whenever you're adding an Active Directory domain controller to your virtual network and you need a static IP address to give your virtual network's DNS server. So in that case, you would need to have a static IP address that you could rely on. And so that suits that particular scenario. And I think what I just said there might make more sense once we talk about virtual networks in an upcoming module. So we're getting there. Hang in there. You're doing great. We'll see you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I want to talk about the relationship between virtual machines and cloud services. Now, up to now, I've avoided talking about cloud services on purpose. Back in the websites, Azure Websites course, you'll recall that I explained how cloud services are somewhere in between Azure Websites and Azure Virtual Machines in terms of hosting websites. So it's somewhere in between the scale of all the way on the one end where you have a platform as a service and all the way on the other end where you have infrastructure as a service. And I also said that much of what cloud services did for you in the past has been usurped by Azure Websites and Azure Web Jobs. However, cloud services still play an important role in Azure, as we're going to learn in this module. So let's start out with a little bit of history. When Azure was first released, there were a limited number of services that were available. And one of those early services were called hosted services. Hosted services provided you two types of computing, a web role and a worker role. So the web role could host websites, and it generally was the presentation tier of your application architecture. The worker role could perform background processing, and so it kind of supplied the middle tier of your application architecture. You would typically communicate between those two roles using message queues. And so the web role would receive some inquiry from a client, a web browser, and then as a result of that, write a message into a message queue. The worker role would then every once in a while read messages out of the the queue, perform some business logic on those messages, and then save them into a database like an Azure hosted version of SQL Server. And so the worker role ran continuously, polling the queue, saying, do you have anything new? Do you have anything new? Do you have anything new? And it was a lot like web jobs that we learned about in the Azure Websites course. You could tell it to go to sleep for 5 seconds and don't check until your 5-second wait time is up. Then check the queue for a new message and then go back to sleep for 5 seconds, that sort of thing. Okay. So as a developer, you could determine how many web role instances and web worker instances that you needed for your application, and then you would configure the number that you needed in a special XML file called a cloud service package. Now, actually, Visual Studio gave you a property editor, a nice little visual editor that will allow you to create that XML file so you don't have to get your hands dirty writing raw XML. But not only would you define how many instances of worker roles and web roles that you needed, but you'd also define there how many CPU cores, RAM, and so on that you wanted for each instance of that given role. So once you built your application and you created this configuration file, then you would upload all of that stuff to Azure. In about 10 to 15 minutes, your application was up and running and all was well. And if you ever needed to scale up or down for either role, you would just change that configuration file, change the number in the XML, and upload it in about 10 to 15 minutes. Your app's boxology was updated. How many instances of your given roles were actually up and running. Now, under the hood, each role instance hosted a Windows server where your application code would actually execute. So Microsoft then handled all of the service management, the patching, the security fixes, and the failure management of the Windows server that hosted the roles that you, the developer, uploaded, so that you didn't really have to worry a whole lot. They took care of a lot of those infrastructure bits. The role itself was housed inside of another container called a hosted service. The hosted service provided network services and in particular an IP address that was in turn connected to the load balancer. The name hosted services at some point got renamed to cloud services, and it pretty much works like this today. You can still create web roles and worker roles in Visual Studio, although, as I pointed out previously in the Azure Websites course, it's been overshadowed by Azure Websites and Azure Web Jobs. Now, what's interesting about the cloud services architecture is that a real Windows server is hosted inside of a role in a cloud service. So why not allow customers to create virtual machines that sit inside of a role in a hosted service, and then they can install and run anything that they want in that Windows server? This would give companies a way to migrate legacy systems into Azure, that lift and shift approach that we talked about at the very outset of this course. So in June 2012, Microsoft announced Azure Virtual Machines, and they were designed to fit into the existing cloud services infrastructure. And while they're represented in the portal as two different things, as virtual machines, and then later on you can see cloud services, they're actually related, closely related. And you see this whenever you create a new virtual machine via the gallery route like we've been doing. In step number 3, you're asked to select a cloud service. Now, you can put the new virtual machine in an existing cloud service, or you can create a new cloud service. That means, yes, you can put multiple virtual machines in cloud service. And when you do, they have network access to each other. And I'm actually going to demonstrate that in an upcoming module, I believe in the next module. And while that is possible, you can do that to communicate directly with each other inside of the cloud service. Virtual networks are really the recommended way to connect virtual machines in Azure. So when would you put multiple virtual machines inside of the same cloud service? Well, the best practice is to configure each tier of your application into a separate cloud service. So I want you to recall the diagrams that we looked at previously. You should recognize these. Here's one where you see that there are 3 virtual machines and it's inside of a boundary, these dashed lines. And I didn't really acknowledge that previously when we looked at this diagram, but that is implied to be a cloud service. And then you'll recall this much more advanced version of that. And you see that there are virtual machines in one boundary and then virtual machines in another boundary. There's the boundary at the top is called the web service tier, And so they've put all the virtual machines in that tier inside the same cloud service. And then they put all the virtual machines that belong to the database tier inside another cloud service. And you can see that all the virtual machines then communicate with this outside boundary that is indicated by the two angle brackets, which is the virtual network. So again, what's inferred by these diagrams is how the VMs are grouped in the cloud services, that little cloud plus gear symbol, and they were grouped by their tiers in a given application's architecture. So to recap and hopefully to clarify, virtual machines must live in a cloud service, and that acts as a container and provides a unique public DNS name, a public IP address, and a set of endpoints to access the virtual machine over the internet. And you should group virtual machines that belong in the same tier together. Furthermore, the cloud service can optionally be in a virtual network, and that is the recommended way to go about it. So let me ask you this. What happens whenever you delete all of the virtual machines inside of a cloud service? Does it automatically go away? Well, actually, it won't go away. You'll have an abandoned cloud service. So if you decide that you want to delete all the virtual machines for a given application tier, you're going to have to manually delete the cloud service then if you want to remove it. And an empty cloud service doesn't really cost anything. You might want to keep your list of services tidy like I do and delete anything that you don't need. Or since the cloud service is what provides the IP address, I think you can create a new virtual machine inside of the abandoned cloud service, and the newly created virtual machine will have the same IP address as the deleted virtual machine. I think that's true. Okay, so hopefully by understanding how cloud services work and the role that they play in actually hosting virtual machines, even if we're not going to discuss them at length in the series, you can also see how virtual machines work under the hood, how they're provided the services that they need in order to work inside of a networked environment or be accessible over the internet. And communicate with the load balancer and all that good stuff. Okay, hopefully that was a good little background lesson for you. Let's continue on and see a practical application of this in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In the previous module, we said that it's a best practice for virtual machines that are in the same application tier to be added to the same cloud service. Now this would allow them to communicate with each other and some other benefits. Now, while I'm not quite ready to talk about virtual networks just yet, I will demonstrate that two virtual machines can in fact communicate with each other when they're configured to live inside of the same cloud service. But as you'll see, it's not a very robust communication mechanism, but it is possible. So here we go. So we're going to start by creating a cloud service. We could just create a cloud service in the course of creating our first virtual machine, but this way we get to take control of the naming process. So we'll choose Custom Create, and I'm going to call this Bob CS for Cloud Service. And I'm going to choose the East US region, and then hit Complete. Alright, so that is complete. The next order of business then is to start adding virtual machines to it. So let's create our first virtual machine from the gallery so we can take control of the creation process. We could just go quick create, I guess. Nah, we'll go from the gallery and we'll just choose the default. I'll give this the name Bob's CS VM1 for virtual machine 1 to borrow and my password. And then I'll hit next. And here I'm going to choose the cloud service. So this is the critical step right here. I'm going to choose Bob CS, which we created just 30 seconds ago. And I'm going to select the East US region. And I'll just go ahead and create a new storage account, and I'm not going to choose an availability set, and I'm good. Let's go hit complete, and I'll follow the same steps to create my second virtual machine. I'll choose all the same options. I will name it differently. We'll call this Bob CS VM2, and I'll use my typical username and password. Now the usernames, I don't have to use the same usernames, but it'll come in handy whenever we try to have these two talk to each other, because they're going to need permissions on each other's computers, and it'll automatically be set up if they both have the same username. All right, cloud service, make sure that it's Bob CS, and then I want to choose the East US region. Click next, and then complete. Okay, so it seems like the first one is done. Let's go ahead and connect to it. I'll save the RDP file down to my downloads directory. And in Windows Explorer, I'll try to find that file. There it is. And I'm just going to drag it out to my desktop. Now I'm going to right click and select Edit, and I'll make changes to the Remote Desktop Connection dialog, adding my username, changing the display size, all the usual steps that I take. And I'll save those changes, and I'll go ahead and connect. Yes. All right, so it's going to set up the desktop. It'll take a second. Meanwhile, let's come back over here, and it looks like the second virtual machine has finished, so we will go ahead and click connect, grab the RDP file, open up Windows Explorer, drag that RDP file to the desktop, if I can find it here. Alright, I just needed to refresh it, and I'm going to drag it to the desktop now. I'm going to edit that one just like I did the previous connection. And I'll connect to it. And it's setting up the user for that virtual machine now. Let's go back to machine number 1. I'll go ahead and say no, we don't want to search for other computers on this network. We don't really need that. Click no. And now let's open up Windows Explorer. Click no on that on the other VM. Back in the first VM, I'm going to create a new share folder called Bob's Share 1. I'm going to right click it and select share with specific people. Let's select to borrow, make sure it has read-write privileges, and then click the share button. I'm going to select no. Alright, there we go. So it looks like that one is shared out. Now let's go to the virtual machine number 2. Do the same thing. We're going to call this Bob Share 2. And then I'm going to right click it and say share with specific people. Obviously want to select to borrow and select share. I'll select no, and there we have it. That folder is shared out. Inside of that folder, I'm going to go ahead and create a text file, so we just have something in there, and I'll name it from 1, or from 2 rather, sorry, and I'll just say this is from 2, and I'll save that file. So now we have at least have a file there. Now I'm going to go back into number 1. I'll create a new text file inside of Bob Share 1 called from 1, And I'll put that same text in there. This is from 1, and save it. Okay, so now on Bob's Share 1, I should be able to navigate to Bob's CSVM2/Bob's Share 2, and I can see the from2 text file. Very cool. And I can open it up, and it has the contents of that file. Let's try the same thing over here. And we'll go up to the location bar and type in whack Bob's CSVM1/Bob's Share 1. And I must have spelled it wrong. What did I do here? Oh yeah, I missed an S. All right. Okay, and we can see the file from 1. Awesome. And we can open it up, and it has the contents from 1. Very cool. Okay, so we were able to allow 2 virtual machines to talk to each other on the same cloud service. They didn't need a private network. They didn't need to be networked in any other way. They're networked by virtue of the fact that they sit in the same cloud service. Very cool. All right, so let's pick it up in the next module. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this brief module, I'll formally introduce virtual networks. Now, I've already spilled the beans. I've referred to virtual networks several times in this series up to now. I couldn't avoid it. And at some point I said it is exactly what it sounds like. It's a network of virtual machines. Now, let me give you a little bit more formal definition here. A virtual network, sometimes referred to as a VNet, serves as a private network over which your virtual machines can communicate with each other safely. So, virtual machines or other services that are outside of the virtual network cannot communicate with virtual machines or services that are inside of the virtual network. So, a virtual network provides a layer of security by isolating your virtual machines from the rest of the world. However, you can create a secure connection between your company's on-premise network and your Azure virtual network through an Azure Virtual Network Gateway. Azure Virtual Network Gateway. So you can have some servers on-premise that are securely communicating with services on Azure. So this is usually referred to as the hybrid cloud. This type of connection that I actually have been playing out here for you is referred to as a site-to-site connection. Furthermore, you can create a secure connection between a single computer and your Azure Virtual Network. This is called a point-to-site network, or VPN. And I'm going to demonstrate how to create one of these in another module coming up. So with the site-to-site and the point-to-site networks, your communication with Azure is secure. However, it is transmitted over the public internet. So that does introduce some risk and some variability to your connection. Now, if your organization requires more security and connection stability, you can always employ the Azure Express Route product, which is essentially a private network connection managed by a special service provider. The isolation from the internet that it provides not only gives you more security, not only gives you more reliable connection, but it also gives you faster transfer speeds. And to learn more about ExpressRoute, you can see it here on this link on screen right now. So, in a nutshell, you would use a virtual network for 3 different reasons. One, you'd create a virtual network to create a dedicated private cloud-only virtual network which allows your virtual machines and cloud services inside the virtual network to communicate directly with each other in a secure fashion. So this keeps traffic securely within the virtual network, but it still allows you to configure endpoint connections for the virtual machines that require internet connections as part of your solution. So in other words, if some of those virtual machines in your virtual network need to be public-facing Internet Information Services, you can definitely configure it that way. And the connection between those virtual machines that are serving up web pages in IIS and those virtual machines that are actually storing data in a SQL database, that communication can be private and secure within the virtual network. All right. So that's one reason why you'd create a virtual network. You'd also use a virtual network in order to, secondly, securely extend your data center, so a company's data center, so that you can build a traditional site-to-site VPN to securely scale your data center capacity by way of a virtual network gateway. So it's that site-to-site scenario where your company wants to start expanding out into the cloud, so it starts using virtual machines inside of the cloud in a private virtual network, and it can start using services from the cloud even on-premise with your on-premise servers, and it can communicate just as if they were on the same network locally. And then the third reason why you'd use a virtual network is so that you can enable hybrid cloud scenarios, so that you can connect cloud-based applications to your on-premise systems like we just mentioned a moment ago. So also, to recap, there's actually 3 types of connections to enable cross-premise connections. Hopefully you remember these: site-to-site, point-to-site, and express route. So site-to-site is when you connect your company network to a virtual network in Azure. Point-to-site is whenever you connect a single computer to the virtual network in Azure. And then express route is where you have a direct secure connection from your company's network to the virtual network in Azure, but it's not transmitting data over the public internet. Okay. Now, there are many, many variations on these types of connections. I'm going to call these advanced scenarios. They're advanced to me. I'm not a network guy. They might make a lot of sense to you. For example, it's possible to create a multi-site VPN. So this would allow you to connect multiple on-premise sites, like your office in London and your office in New York and your office in Chicago, to a single virtual network gateway. And so if you want to learn more about that, there's a diagram here on this page. Actually, there's the diagram on screen as well that will kind of show you that topology. So when you set it up like that, your applications can access resources across different corporate locations and regional private networks as well. Another variation on the idea is an in-region VNet to VNet and a cross-region VNet to VNet. So a VNet to VNet connection utilizes the Azure VPN gateways to connect 2 or more virtual networks together securely. But at any rate, I guess the point I'm trying to make here is that you have a lot of network connection topology options. You can create geo-redundant SQL Server virtual machines that use the always-on client to automatically fail over across regions if necessary, because they're all part of the same virtual network. You can communicate across Azure subscriptions. You can create a multi-tiered application with tiers living in different areas of the world, or even between different companies, different organizations that want to partner together. So again, those are all advanced cases, advanced to me, and if you're like me, I can't wrap my head around all of that. So here's a simple diagram that answers the basic question, do I even need a virtual network? You can find this at the URL on screen right now, and you can see this image, which basically just walks you through a yes-no, and it asks a few questions, and that'll help you determine whether this is for you or not, for your company, or if this is something that wouldn't really be something you're interested in. Okay, so moving on, a few modules ago we talked about how 2 or more virtual machines could share a single cloud service. And I demonstrated how those virtual machines could communicate with each other securely in a private fashion. Now, they were just doing simple file sharing, and it's fine for that, but can those virtual machines that are hosted in the cloud service be part of a virtual network too? Well, absolutely. In fact, if a cloud service is not in a virtual network, or rather the virtual machines in the cloud service are not part of a virtual network, then virtual machines in that cloud service can only communicate with other virtual machines through the use of those other virtual machines' public DNS names, and that traffic would then travel over the public internet. However, if the virtual machines in a cloud server are part of a virtual network, then they can communicate with other virtual machines in the virtual network without sending any traffic over the public internet. Okay, so in a nutshell, just to kind of strip out the whole notion of a cloud service, it doesn't really matter whether there's a cloud service or not. A virtual network is the key to a private, secure communication, regardless of whether each virtual machine is in its own cloud service or whether it's grouped together in a single cloud service, or if they are grouped in multiple cloud services. Okay. So the last thing that I'm going to mention is that with a little planning up front, it'll help you integrate your existing network with the Azure Virtual Network if you're going to create a hybrid architecture like we talked about, that site-to-site topology. You're going to want to figure out the topology of the virtual network that you're going to create, the address space and the subnets that you're going to use, and make sure that you select ranges for the virtual network that don't overlap with other networks that you're going to connect to. You'll also want to determine whether your network will feature a DNS right up front, because it will be more difficult to add one later on. Of course, if you're a seasoned network administrator, you already know this stuff. You know it better than I do. But just be forewarned, you should probably do a little planning ahead of time. All right, so there are two ways to create a virtual network. The first is by creating a network configuration file and then importing it into Azure. And then the second method uses the Azure portal. Now, for simplicity, I'm going to demo the second method. However, you'd want to create a configuration file if you're going to automate the deployment in the future, even perhaps on a different subscription. So you can create the virtual net using the portal, then export a configuration file that represents your settings, and then you can tweak that file in Notepad if you like, and then upload it to create a new virtual network with basically those same settings with the tweaks. All right. And so for more information about using the network configuration file, take a look at the link on screen right now. And furthermore, there's a great list of many common virtual network configuration tasks, some of which we're going to cover in the next few modules at this URL as well. Now, since I already confessed that I'm not really a network guy, I'm going to keep the demos really short and to the point. This is one area that you can dive in much deeper with other content available on Microsoft Virtual Academy from instructors that are much more qualified to talk about this than I am. But in the next few modules, I'm going to demonstrate the basic set of tasks of several of these, like a point-to-site and a cloud-only virtual network and things of that nature. So let's get started in the very next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll create a cloud-only virtual network. Now, honestly, the concepts that we already covered are more difficult than the steps that we're actually going to use to create this virtual network. But I'm going to split this into two parts. In this module, we'll create the cloud-only virtual network, and in the next module, we'll connect two virtual machines to that network and see if they can, in fact, communicate with each other. So let's go ahead and get started. So as you can see, I've already created a virtual network, but I want to create one from scratch on camera. So I'm going to go to the New menu, select Virtual Network, Custom Create, and I'll give the new virtual network a name, call it Bob's CON for Cloud Only Network. And I'll select a region. I always select the East US, and then I'll select Next. And since this is a cloud-only network we're building, there's really nothing on this page for me to modify, so I'll click Next again. And again, since this is a cloud-only network, I won't need to modify the address space or the subnets because I'm not really worried about collisions with my on-premise network. So I'm done here. I'm going to go ahead and click the Complete button. And then the next step that I'm going to take is to create a cloud service to add my virtual machines into. Now, strictly speaking, I don't have to do this. I'm choosing to do this because I'm going to simulate multiple VMs that are serving the same purpose in my application architecture. And as we said previously, this is a best practice to go ahead and put all the machines at a certain location, all in the same cloud service if they're serving the same purpose in the application architecture. So I'm going to go ahead and create a cloud service. I'm going to give it the name Bob's Con Middle Tier to simulate that several virtual machines will serve the purpose of being in that middle tier. And then I'm going to select the East region and save the cloud service. and I'm going to click the complete button. And that's really all I wanted to do in this module. In the next module, I'm going to show you how to add virtual machines to our new cloud-only virtual network. Obviously, this will be pretty simple, but we'll pick it up in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In the previous module, we created our cloud-only virtual network. And now in this module, we're going to connect two virtual machines to that network and see if we can get them to communicate with each other. Now, if this was a real virtual network, I'd probably create a domain controller, set up DNS, employ Active Directory to create user accounts, and so on. But I'm going to keep it simple and just perform a simple network share between the two virtual machines on the virtual network. So let's go ahead and get started. So if we take a look at our cloud service, there's nothing deployed to it just yet. So the next step is to create some virtual machines and add them both to the cloud service and to the new virtual network. And so we've created virtual machines several times before this. We'll just go to New, Compute Virtual Machine from Gallery. I'm just going to choose Windows Server 2012 ARC2 Data Center. I'm going to give this the name Middle Tier 1. I'll also create a Middle Tier 2. And I'm going to fill in user credentials just like always. And I'll hit the next button. So here's where I want to choose the cloud service that I created, which was Bob's Con Middle Tier. And I'm going to change the virtual network to Bob's Con. And you can see that it already filled out the virtual network subnets and things of that nature. I could add an availability set here. I guess we'll call it Bob's Con Middle Tier. Too long, huh? We'll call it Bob's Middle Tier. And it seems to be happy with that. I'll click Next. And then I'll just go ahead and let it install the virtual agent. I'll click Complete. Now it's going off and creating that virtual machine. Okay, now since that one's finished, let's create another one just like it. I'll choose all the same options. I am going to name it differently. I'm going to name it Middle Tier 2. But I'll give it the same username and password just so I don't confuse myself. And here I'm going to choose the same cloud service, Bob's Con Middle Tier, and I'm going to choose the same virtual network. It actually is already selected for me for Bob's Con, and I'm going to choose the Bob's Middle Tier availability set. Hit Next, and I'll hit Complete. Okay, so they're finished. Now I'm going to go to the dashboard for Middle Tier 1 and I'm going to try to connect to it. I'm going to save the RDP file to my downloads directory. I'm going to do the same thing for Middle Tier 2. Click Connect, download the RDP file. Now I'm going to open up Windows Explorer, navigate to my downloads directory. And I'm going to do what I always do, which is to, first of all, let me find them. All right, there they are. I'm going to drag them onto my desktop, and I'll go ahead and edit both of them. Just changing up the, adding my login credentials, and then changing the display size so it stays within the recording area. That's good enough. Save that. And now we'll click Connect. Yes, 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 yes. Connect. Yes. All right, so while that one is building out the desktop, let's go ahead and do the same thing for the other one, Middle Tier 2. Pop in my username. Change display. Save all that, and now connect. Yes. All right, there we go. Now I got two. Of course, they're getting set up at the moment, but soon we will be able to get at each of them and create a shared folder so that they can see each other's files in that shared folder. All right, so let's start with middle tier 1 and open up Windows Explorer. And I'm going to navigate to the C drive. I'm going to create a new folder in the root, and I'm going to call it Share 1. I'm going to right click it and select the share with specific people, and I'm going to choose to borrow, make sure it's read write. I'm going to say no to make it public, and you can see that I have a shared folder on the first virtual machine. I'm going to put a file in. I'm just going to create a new text document, and I'll just call this share 1, and I'll just type in some text. This is shared from share 1 or something like that. Save it. Now let's do the same thing on our other virtual machine, middle tier 2. This time I'll name it Share 2. And I'll go ahead and create that text document again just so we can know what we're looking at. Add some text in here. This is from Share 2. All right, now we've got to make sure to set the permissions. Right click, share with specific people. Make sure to borrow is selected and hit share. Click no. And looks like they're both shared out. Great. Click done. Now, I should be able to go to the location bar and just type in whack middle tier 2 / share 2 in order to see its files on middle tier 1. And I do. And we should be able to do the same thing, whack middle tier 1 / share 1 in order to see share 1's file from our middle tier 2 box. Very cool. We did it. Again, if this was a real virtual network in a real company, I would go through the extra steps of creating a domain controller and set all that stuff up. But that's for a more networky kind of person to show you how to do. So this is a great step. We've pretty much done the exact same thing that we did before with virtual machines, but at least now we're running in the context of a virtual network. And so next thing we're going to do is create a point-to-site virtual network to allow us to add our own local computer to the virtual network, which will be cool. All right, we'll start that in the very next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. Now that we've created a cloud-only virtual network, it's time to take the next step and create a point-to-site virtual network, and that'll allow us, actually allow our client computers to connect to a virtual network in Azure through a VPN. So I'm going to split this actually up into 3 different parts. So in this module, we're going to create the point-to-site virtual network, and then we'll create the virtual network gateway to allow clients to connect to that network. And then in the next module, I'm going to generate and upload security certificates to authenticate my client with the virtual network. And then finally, in the third part, I'm going to actually use the VPN utility that I'm going to download from the Azure portal to connect to the virtual network and share files between a virtual machine in Azure and my own local computer. That'll be cool. So let's go ahead and start. So the first step is to create a new virtual network. I'll go to the New menu and choose a Custom Create. I'm going to give the virtual network a name, Bob's Point to Site, and I'm going to select a location of East US. I'll click the next button, and on the DNS servers and VPN connectivity page, I'm going to choose the checkbox next to configure a point-to-site VPN. You can see that this adds a little visualization now between the Bob's point-to-site network and the clients, and then there's the gateway in between them. So I'm going to click next. On this next page, I can configure additional address spaces, and here I can ensure that the address spaces that I'm going to use are not going to overlap with ones that are used on my clients. I'm not going to make any changes here. I'll just click the next button. On this final page, I can add a gateway subnet, which is what I'm going to do, and then I'll click the complete button at the bottom. And now we wait for it to create our new point-to-site network. And so my goal here is to create a network between my local computer and a virtual machine up on the new network that I created. So I'm going to create a new virtual machine, and I'm going to make sure to add it to this network. So obviously the key here is where it's currently selected West Europe as the region, we want to instead select our new virtual network to add this virtual machine to. And just for fun, I'll go ahead and create an availability set too. And we'll go ahead and click complete, and we'll wait for the virtual machine to be created. Actually, while that's being created, I'm going to go and look at my virtual network, and I want to add a virtual gateway at this point. I'll click the Create Gateway button in the bottom menu bar, and it's going to make me confirm that I actually do want to do this, and I'm going to click Yes. And so at this point, it's going to take a while for both a virtual machine and this gateway to get set up. You can see that under Resources, our virtual machine has been assigned to this network, so it's making progress, but honestly it's going to take probably a minute or two. So I'll stop this module here, and we'll pick it back up in the next module. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In the previous module, I set up the point-to-site virtual network in Azure, and I added a virtual network gateway. So we're all set there. The next step is to create two certificates. I'm going to create one so that I can upload to the virtual network in Azure. It's the root certificate, and then I'm going to create a second certificate that I'm going to install on my local computer in the local certificate store. And once I do that, then I'll be able to establish a secure connection from my client computer to the virtual private network. All right, so let's pick it up right where we left off from. So as you can see, our gateway was created. You can see that we now have an IP address, and if you look to its left, you can see that it's tracking data in and out, so that's great. However, you can see that there's a little red box around the client visualization, and it says for each client, actually it says a root certificate has not been uploaded. So for each client that wants to connect to this gateway, we're going to have to upload a root certificate created by that client to the virtual network and to the gateway, and then we're going to have to install the matching client certificate on the client. So in order to do this, we're going to have to bail out to the Windows command line. So actually, you don't want to just open up the Windows command line tool. You want to open up the Visual Studio version of it. Every edition of Visual Studio seems to call it something different, so you might have to hunt around for it in the Windows Start screen or wherever you would go to find it. But essentially, this is going to give you access to the Make Cert utility that comes with Visual Studio. So I'm going to go and first of all create a new folder called Cert in the root directory on my C drive so that I can easily navigate to it whenever I need to upload that management cert to the Azure portal. And now you can see that I have Notepad open, and I've got a command that I just copied directly from MSD, and I didn't make any changes to it. You can search for this online, and I'm going to copy and paste this into the command line, and this will create a certificate in that cert directory that I can then upload to the Azure portal. So you can see that this created a certificate successfully. If we do a listing on the directory, you can see that we have a root certificate name.cer. So we're in good shape. So the next step is to go back to the Azure portal, go to the Certificates tab, and then click the Upload button in the menu bar at the bottom. Here I'm going to navigate my hard drive to find the cert folder that has the root certificate name.cer, and once I find it, I'll click the Complete button. And that looks like it's installed successfully. So now we're going to go back to the command line, and we're going to create a client cert. And here again, I'm going to copy the actual command from an MSDN article, and I'm going to paste it here in the notepad just to inspect it before I copy it and put it back into my command line tool and to create the client cert. And as you can see, it created successfully. Now if I do a listing on that directory, you won't see the certificate here. Instead, I'm going to have to use a different tool, the Cert Manager. So I'm going to go ahead and launch that from the Windows command line. And as you can see, the Certificate Manager has both our root certificate and our client certificate installed. We can inspect the client certificate, look at the the details and the certification path, and even inspect it in a dialog. But there's really not all that much interesting here. Nothing really that we can do at this point. So let's go ahead and exit out of that. And so we've completed that crucial step. So we're 2/3 of the way done. We'll pick it back up in the next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In the previous two lessons, we created a point-to-site virtual private network. We created a virtual network gateway. And then we created a root certificate and uploaded it to the VPN in the Azure portal. And then we created and installed a client certificate to ensure authentication and secure communication between the two. So now in this third part of our saga, I'm going to download the VPN client from the Azure portal. And I'm going to connect my client computer to the VPN and exchange files with a virtual machine that's in Azure that's on the same VPN, the point-to-site network. All right, so last part, we're almost there. Let's get started. So since I'm running Windows 8.1 64-bit, I'm going to want to download the 64-bit VPN client. This executable is generated for my specific VPN. Now, when you download it, you're going to get some warnings that say, hey, this could potentially be harmful. That's because it's created on the fly, again, with your VPN settings, so they couldn't digitally sign the executable, and so you're going to get that security warning. Do it at your own risk, but you're going to have to run this in order to connect to your VPN, so you can ignore that security warning and just go ahead and run the application. We'll click yes because we do want to install the VPN client. And after it's finished installing, you'll want to go to the charm bar and go to settings and then click on the name of your network. Mine is Obi-Wan Kenobi. And so the act of clicking on that network name will open up all of your networks, and you should see your point-to-site network listed there. And when you click the connect button, it will then open up the VPN connection utility. And so it'll ask if it can run in elevated permissions because it needs to change the routing table. So I'll go ahead and click continue. And so while that's working, I'm going to pop back over to the Azure portal, and I'm going to go to the virtual machine that I created in a previous step. And my goal is to log in to that virtual machine using RDP,
And then what I want to do is create a folder that I can share out. So ideally, what would happen is my local computer could see that share out on that virtual machine up in Azure. So I'll just take a minute to configure the RDP connection, changing the display size and putting in my credentials. And then I'll log in and wait for it to create the desktop. Now my first order of business is to find the command line utility because I want to run ipconfig all and make sure that this virtual machine can see out to the virtual network. So after running the ipconfig/all utility, if I scroll up near the top of the output, you can see that I am indeed connected to my virtual network. So that's great. Now the next job is to go to Windows Explorer, and on the C drive I want to create a new folder. I'm going to call it Bob Share. And once it's created, I'm going to right click it and select Share with specific people. And so when the file sharing dialog opens, you can see that there are two users, I guess. There's a group, administrators, and then there's a user to borrow. And one thing I failed to mention earlier is that I made the login name for both my local desktop and for the virtual machine the same, so that it's the same username and they should be able to share with the same password, so they should be able to share without having to create new users and stuff like that. You don't have to take that step, but this streamlines the process a little bit. So I'm going to go ahead and select to borrow and then click the share button at the bottom. So when the network discovery and file sharing dialog pops up, it'll ask you if you want to turn on network discovery. I'm going to go ahead and select no, make the network that I connect to a private network. And then once I do that, you can see that that share folder, Bob Share, is shared out with Tabaro. So I think I'm done here. I'm going to minimize everything, get back to my desktop. And I'm going to open up Windows Explorer, and in the location bar, I'm going to type in the IP address. So whack 10.0.1.4/Bob Share, and that should get me out to the virtual machine out in Azure from my local computer. So this looks promising, but there's nothing in that folder. So let me go back to the virtual machine and find that folder, and I'm just going to create a new text document with just some random text in it, just to see if I can see it from my desktop. And as soon as I create that file, I go back to the desktop, and sure enough, it's there. I can open it up, look at the text, and so we've successfully accomplished what we set out to do. So that's pretty cool. We created a point-to-site network. We're able to share out a network drive. So now I have my local computer in the same virtual network as my virtual machines up in Azure. All right, so I think that just about does it for virtual machines and virtual networks. Now let's move on to past infrastructure as a service and back to a few items related to platform as a service. We'll see you in the next module. Thank you.
Hi, I'm Bob Tabor with www.learnvisualstudio.net. So we just finished looking at Microsoft Azure's infrastructure as a service offerings by learning about virtual machines and virtual networks. That's great. Now what I want to do is move on to other Azure services that really didn't fit nicely into any of the other courses that we've studied until this point. So we're going to start by examining Azure Mobile Services, and then as we finish up this series of courses, we're going to take a whirlwind tour of other services from Azure at a very high level. Probably not all the services. I'm not even sure I know all of the services. They keep coming out with new services every single day, but we'll cover the most popular ones. Okay, so Azure Mobile Services, Microsoft Azure Mobile Services, or MAMS. I think Microsoft saw a real opportunity with designers and developers who build mobile apps on iOS and Android platforms, not to mention Windows developers who focus on phone and tablet applications. Many of the designers and developers that they saw who are front-end developers and designers, they really just focus on the front end, the presentation tier of the application. They've built a great deal of proficiency in building beautiful front ends that are aesthetically pleasing, that follow certain guidelines for that given platform. However, they may not be quite as versant in implementing a cloud-based data store or authentication and authorization or including notification services. These sorts of things traditionally required a vast set of additional knowledge. So, Microsoft introduced Azure Mobile Services to help designers and developers build a back end to their front end. Developers, really all they got to do is just call into a single client API that's created in such a way as to have a familiar feel to their current client platform and provide an easy to use web-based user interface in order to develop and configure and monitor these back-end services. So in other words, in addition to having the Azure portal, an iOS developer can work with an iOS client library, and an Android developer can work with an Android client library, and so on. So MAMS provides a common set of back-end services that can be utilized quickly by designers and developers without a lot of back-end expertise. Now, I also want to say that the marketing term mobile services is a bit of a misnomer, because there's really nothing preventing you from using this in an ASP.NET application, a Windows desktop application, or any type of application. There's also a .NET client, a C++ client library, so that pretty much covers almost all the bases. On the back end, developers can use JavaScript or .NET if they require any custom functionality. Now, many mobile apps may not even need this because the functionality from MAMS is so rich, or they might need some small custom functionality on top of whatever MAMS has already provided. And you might be wondering, well, what functionality does MAMS provide? Well, here's a list on screen, obviously. And the good thing about this, too, I just want to point out before we go into these, is that you can kind of pick and choose the ones you want. If you only need one piece of this puzzle, then just use one piece. If you only need, like, identity, for example, or just data storage. So you can see that here are the backend services. Push notifications, so you can get toasts on your mobile device. Identity, whether that is logging in through Active Directory, in an enterprise environment, or using social logins like Google+, Facebook, Twitter to log into an application, and also get functionality from those applications as well. The ability to access the data from those applications if they give permission. Running scheduled jobs, yes, you can do that in other services from Azure, but it's provided here kind of as a part of this puzzle. Also, just like that, data storage. And you'll see that data storage and API hosting are really only available if you're using or building backend services with JavaScript. C# already has these services available. You're probably going to deploy from Visual Studio anyway, so you'll probably use like Azure Websites and Azure SQL Database for those purposes. And then there's also some enterprisey stuff that you can add to the application. You can connect to on-premise data. You can use Active Directory and things of that nature. Okay, so what client-side libraries are supported? They have libraries for universal apps, .NET and C++, like we would expect. But they also have libraries for iOS and Android. So again, if you're already one of these developers, there's a certain style or heuristic that's used by each platform. And so I think they've stayed true to that in the client libraries. Of course, on the back end, they're calling out to the RESTful HTTP API that we've talked about all throughout this series of courses. They've also got a client for Xamarin, iOS, and Android. And then finally, they also have library, a JavaScript library that you would use when you build HTML applications. And that would cover a wide swath of other mobile technologies that are based on using HTML, CSS, and JavaScript to build their front ends. So that opens up even a wider range of potential client libraries or clients that can be that can utilize Microsoft Azure mobile services. And then there's additional client-side features like offline data sync. So if your user can't get to the internet, your app doesn't have to just say, "Sorry, can't connect." There's a big box retailer whose application I try to open once in a while, and for whatever reason I get an error message, "Sorry, can't get to the store right now," and then it shuts down. I'm like, "Wait, don't you have some of the product catalog there? You know, what was yesterday's daily sales or something? Give me some information. Don't just shut down." So you're able to do that or provide that functionality with client library features like offline data sync. You can also query data tables, like I think we'll demonstrate in one of the upcoming modules as well. And one of the neat things that I think they saw an opportunity to do was to provide an example to do apps. So basically, once you create your Azure mobile service, one of the first things that you'll see on the dashboard is the ability to download a client app based on which library you want to use. So say I'm an iOS developer, I can download a zip file. It'll have code in there with my my application key already encoded and references to the URL for my application. So it's a really nice quick start. I think it runs pretty much out of the box, and then you can start picking that apart and learning how to do things with Azure mobile services. So that's a really neat feature, and we're actually going to look at that in the very next module. All right, in addition to the client-side libraries, there are back-end libraries. The first one is, and I think I've mentioned this, there's two of them, .NET and JavaScript. So there is the mobile services .NET back-end library, which you can find a reference to here at this URL. And then there's also the mobile services JavaScript back-end library. Now, the cool thing about the JavaScript library is that I'm learning Node.js, I'm learning Express.js, and I think that's the next big thing in my personal opinion. But at any rate, you're essentially you're using JavaScript plus, in some cases, Node and Express functionality. For example, if you take a look, it can be used to create CRUD triggers. So if you want to, you're going to insert data into the database, you can write JavaScript that will pretty much run like a stored procedure. It'll execute prior to actually inserting. So we're going to see in an upcoming module how I will tack on some extra information to every record that we save in the database. You can create a web API, and here again, this is where Node and Express really comes in. You're really just creating a Node.js module when you create a web API, and we're going to demonstrate that in an upcoming module as well. So if you're already familiar with Node and Express and how modules work and how you export functionality as a module, well, you'll be right at home when you're building web APIs for your application. And this would allow you to do any custom server-side logic before actually accessing the database. You could also kick off notifications. You could send an email from the back end, things of that nature, using a web API. You can create a scheduled job and using JavaScript, and you can access all of those main user objects like the user object, the data object, notifications object. And I have a list of the common objects that are available to you on the back end: the request, the response, the user, the data, the notifications, and there's a bunch more if you take a look at that URL, mams node backend. So bit.do mams node backend. And then I guess the other thing that's both cool and a little discouraging is that it's just like everything else in Azure. It's huge, and we're not going to be able to cover all of it in the few modules that we're devoting to it here. And you could probably spend a month or two just kind of getting to know all of the nooks and crannies of this particular service inside of Azure. So how do you learn it? Well, I'll tell you what I did. I did exactly what I said a few moments ago. I downloaded a generated to-do app, and I picked it apart and just stared at it for 4 hours and tried to change this, change that, try to recreate my own. And then you can go through the extended how-to tutorials on the Azure documentation website. And so they'll take that to-do app and they'll extend it even further by adding push notifications. They'll show you how to add web APIs to add a little bit of functionality to that to-do application. And one thing that I do want to point out, let's see if I have it pulled up here. No. Let's go to a web page for Azure Mobile Services, one of the demos or one of the documentation pages. All right, so I'll just paste. All right, and so I'm just going to paste in the URL here. And this particular one just happens to be server-side authorization of users and mobile services. That's not the important part. The important part is pretty much all the documentation for Microsoft Azure Mobile Services has these two little drop-down list boxes at the very top where you can select what's the client platform, what's the back-end platform. Let me find another one here. Let's see. Authenticating users. Well, let's find a better one than that. All right, this might not be the best example. There's still some others I've seen on some other documents, but here you would say, I'm building an iOS app and I want to use the JavaScript backend. And so based on those selections, it will change up the document and the source code and things of that nature that are specific to using that combination of front-end library and back-end library. Okay, so just be apprised of that. I think that's very smart on their part. That's very cool. All right, so in the next couple of modules, I can't possibly show everything, but what I want to do is point out a few of the less obvious things as I was trying to get started with Microsoft Azure Mobile Services, things that just didn't pop out at me, and I scratched my head and had to go online, and I had to do some extensive searching and, you know, struggled with it. So hopefully I can kind of maybe give you a few things that will help you get started, and then I'll let you take it from there if you want to employ this in your own websites. Okay, so that's pretty much all that I have in this module. We'll pick it back up with a few specific examples. We'll create a new Azure Mobile service in the very next module, and then we'll add some cool functionality to it in the next modules after that. All right, so we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we're going to create our first Azure Mobile Service. We're going to talk about some of the interface elements in the Azure portal. We're going to download a sample application that they'll give us. We'll use the JavaScript client. We'll get it running locally, and so that we can begin to look at the source code and understand how it works. So we're going to try and do all of that in this module. Creating a new mobile service is very easy. We can just click Create New Mobile Service in the main pane, or we can use the New menu at the bottom and choose Mobile Service and Create. It's going to ask us for a URL of Bob's First MAMS. We can use an existing database or create a new one. I'm going to use an existing database that I have, and we'll set up which one in the very next lesson, or rather in the very next step. And so I'm going to choose the region, East US, and the backend will be JavaScript. I'm not going to configure advanced push settings. There's really nothing there for me right now since I don't already have a notification hub defined in my Azure subscription. So I'll go to the next page, and here we get to choose which of the databases we want to use. Now, I created one specifically for all of my Azure Mobile Services. It's called MAMS MS SQL, and so I'll choose that, and I'll give it my password, and that should be all we need to do to get started by creating our first mobile service. Now while that's creating, actually let me go ahead and create a second one of these because I want to show you something that might not be readily apparent at first. MAMS.net. Let's see if that, okay, good, that URL is not taken. I'll use an existing database. We'll go East US again, but this time the backend I'm going to choose is .net, and then I'll click Next. And we'll select our MAMS SQL, MS SQL database, and we'll create that one as well. All right, so now we wait. Okay, so both services have been created. Let me go ahead and start with the JavaScript backend version, Bob's First MAMS, and you can see across the top I have the following. I got the following tabs: Dashboard, Data, API, Scheduler, Push, Identity, Configure, Scale, and Logs. Now compare that with the .NET version. We only have Scheduler, Push, Identity, Configure, Scale, Logs. You see the difference between the two? The JavaScript version has a Data tab and an API tab, and the C# version doesn't. And so if you choose to use a .NET backend as opposed to the JavaScript backend, the data in the API tabs are not visible in the portal because both your data access and any custom APIs that you need are part of your Visual Studio solution, and so you have to deploy them from there. So those won't be part of your Azure Mobile Services solution. So let's just ignore that for now. Let's move on to our JavaScript solution. As I promised, there is a great way to create a Getting Started To Do app. So let's say, for example, that I wanted to have the back end be JavaScript and the front end be HTML JavaScript. I can create a new HTML app, and it gives me this little step-by-step tutorial. First of all, we'll create a to-do item table in our database. Then we're going to download the code, the source code, locally. And then the third thing that we're going to do is configure your host names to allow calls between the domain where your application is hosted, which will initially be localhost, to your Azure Mobile Services endpoint. So this will allow you to bypass the security mechanism in your web browser. So by default, your web browser will not allow AJAX requests from your JavaScript originating from one domain to a server on a different domain name. So there's this W3C standard called CORS, Cross-Origin Resource Sharing, and it defines a way so that a browser and a server can interact to safely determine whether or not to allow cross-origin requests. So it's basically going to allow us more freedom and functionality than purely same origin requests, where all JavaScript that comes from one domain can only interact with web services on that same domain. Now we can make calls to a second domain, but it's more secure than allowing JavaScript to just make calls out to any domain that it wants to. So in this case, it's going to be safe for our page.js file, which we'll download in just a moment. It's going to make it safe for it to call to its origin, which is localhost, but it also make it safe to call back to this Azure Mobile Services endpoint URL so that it can interact and save data and things of that nature. Back, and we'll go ahead and forget our changes there. All right, so the first thing we'll do is create a to-do item table. And now that it's finished, let's go and take a look at our data tab. You'll see that we have one table, to-do item, and there are no records in the table. However, if we take a look at the columns, we can see the basic layout. At this point, there's no custom columns, but we'll see how those get added here in just a little bit. Furthermore, you can see that there is a set of permissions for insert, update, delete, and read. And essentially, every application is going to need this special application key. And we've seen the application key before. Now we can change this setting and say, well, anybody can insert one. You don't need the application key embedded in the application or passed along with the request. We can also choose to only have authenticated users. So we can set up authentication, and we're not going to do that in the next couple of modules, but we could say you have to be, first of all, authenticated through one of the social logins or one of the single sign-on providers. And then the other option is to only allow scripts and admins to perform inserts. So this would essentially be, a script would be either a job, a scheduled job, or a web API running and then making the inserts. But nobody can access the table directly from the client side. All right, so we'll just leave it as anybody with the application key. And let's go back and take a look at where the application key is actually found. Whoops. So like you might expect, we would find the application key here in the Manage Keys icon at the bottom, and we copy out that application key and add it to our app, and we'll see how that comes into play in just a few moments. All right, but at any rate, one other thing I want to point out about the data is that you'll notice that there's really no way to add records here. You can say, let's go ahead and add it, but it'll just pop you back here. And that's not all that useful. So we'll talk about that in just a moment, or in the next module where we actually try to add data to a table. All right, so now we can download and run the application. So we're looking for our downloads directory, we're looking for Bob's first mams.html, and so let me drop that over onto the desktop, and I'll unzip it right there. We'll just put it to, call it to do instead. All right, and so now we have this to-do folder here, and it's opened up in our main area. Now, the cool thing about this is that there's this server folder. If we double click it, there's a number of these different scripts that will allow us to run an instance of the given web server. So in the case of Microsoft, in the case of Windows, it'll run Internet Information Services. I think the others will just run Node. I'm not sure, but I think just Node in order to deploy the application and see it running live. It might use Apache. I'm not sure. I haven't tried it. But if you double-click this Launch Windows, you'll get the security warning, and then you'll get this little command window that says that it will start IIS Express at a given port, and you can say don't run it or run it. And I'll say run once, and it's successfully registered the URL localhost 8000. So now, if I open up my web browser and go to localhost 8000, you can see I've been here before. And if we can convince Internet Explorer to do this, there we go. So we get this is running now off of my desktop, in my desktop folder / to-do folder, and this is the index.html, the style.css, and the page.js files that we see here. Okay? And so it's going to communicate with the backend up in our Azure Mobile Service. First to-do item, second to-do item, and so on. And we can also delete an item. We can say it's finished. Here's the third to-do item, and so on. Okay? So now let's take a look back in Azure Mobile Services and go back to the Data tab, and now we'll look at the data table, and you'll notice a couple of different things. First of all, we have 3 records, but in addition to that, we have 2 new fields, a text field and a complete field. So where did those columns come from? They weren't there a moment ago. Well, basically, Microsoft Azure Mobile Services has this idea of a dynamic schema, and it's enabled by default whenever you create a new Azure Mobile Service. And so when it's enabled, it automatically will generate new columns based on a JSON object that's used in an insert or an update request. So once a column is created, then its data type cannot be changed. So insert or update operations will fail when the type of the property from that point on in the JavaScript object can't be converted to the type that was of the equivalent column that it was originally created. So basically, it dynamically created those 2 fields the first time that we attempted to write data into the database, passing a JSON object with those 2 values. In our case, it would have been like a text would have been whatever it was. Here, let's go back to browse. It would have been first to do item, and the complete was set to false. Okay. Now, like I said, you really can't do much in terms of, you certainly can't add items here in this limited database management tab. You can delete records. Like I'm doing here. And they'll be permanently removed from the database. But you can't edit or do anything else, unfortunately. All right, so there's one last thing that I want to point out, and we'll work with this in earnest in a little bit. You have the ability to write these CRUD scripts. So say, for example, before an insert is performed, we get to essentially inject our own code into that process. So we can stop it, make sure that the user has the correct permissions, validate the data to make sure it's within a given range before we actually then allow that request to execute. And that's, again, true for all of the typical CRUD operations: insert, update, delete, and read. Okay. All right, so that's enough for this module. Well, actually, let's do one more thing. Just to stop this, you just hit just stop it like that. Let's open up To Do one more time. And I'm actually going to open up the index HTML in Sublime. I'll actually open up the page as well and the style sheet. Okay. And Sublime is a text editor that's popular with all the cool kids. So we'll just take a look at this for now. The HTML page doesn't really have much to it other than calls out to the various scripts that it needs. It'll need not only the jQuery script, but also this mobile services .web-1.2.5.min.js. So this is the client-side library for JavaScript. And then it also makes a call out to the page.js. That's where we have our custom JavaScript. In the JavaScript itself, we're going to go through this a little bit more depth in the next module, but essentially the first thing that we're going to do is create a new instance of the Microsoft Azure Mobile Service Client, passing in, and notice what it has done for us. It has already put in here our Azure Mobile Services account name, Bob's First Mams. I didn't have to add that. Additionally, it adds the application key. I didn't have to add that either. All right, and then it sets up a few functions and calls one of the functions here at the very start. So initially, whenever it's supposed to load, it's going to run this refresh to-do items. And refresh to-do items is going to go out to the table and select all records where the complete column equals false. Now that we have that array of items from the database, an array of objects that represent rows in the database, we can then start to perform this anonymous function where essentially we're just saying for all items in our to-do items, all the records that were brought back from our query, perform this function, and that function will essentially just add list items that will be used for each of the items as they're listed on our web page, the to-do items that we've already added. They come complete with a delete button on the right side and a checkbox on the left side, and a input box that's styled up to not look like an input box when we don't have our cursor in it. And that will be courtesy of our style.css page. And then here in our styles, just a bunch of styles to make it look good. So at any rate, you'll see that there are functions to actually handle the various events for whenever the complete checkbox has been checked, whenever the delete button has been clicked, whenever we go to edit the text on a given item. So we edit the text box and change first to do item to my first to do item edited by Bob or something like that. And it will perform these operations. Now the one last thing it's going to do is in each case, it's going to need to know which of the to do items are we currently working with in JavaScript. So it's going to call this get to do item. It's going to pass, when you pass in the form element, it's going to use jQuery to find the closest item with the attribute to do item ID, which will give us the ID that corresponds with the row in the database up in Azure Mobile Services. So again, that's just a whirlwind tour of all of the functionality of this page.js file. Okay. That's pretty much it for this module. Probably said more than I needed to, but hopefully that'll help you gain your bearings as you get started using Azure Mobile Services. So we'll do some more interesting thing in the next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, I'm going to use Azure Mobile Services, and I'm actually going to write an application that will save data into the database and will actually read it back out. I'm not going to show the update and delete case because I just didn't have enough time to add that into my little demo here. Now, you might ask yourself, well, how is this even different than the one that you can download that we looked at in the previous module, the pre-configured one that you can download from the dashboard area of the Azure portal once you create a new Azure mobile service. The difference is that I'm going to show you how to work with not just strings but also integers, dates, and booleans, which that sample just doesn't show you. And I'll just take a different approach just a little bit, and I'll explain things a little more thoroughly, and I'll just be another little way to to expose some of the features of working with data inside of the Azure Mobile Services. So you can see that I've already created an Azure Mobile Service called Data Example. I'm going to delete this in just a moment. And what I didn't do was I didn't create any tables. Now you might see a table here. That's because I created my application locally here, and let me just show you what it looks like here in Sublime. So I have this application here with the index.html, a page.js, and styles.css, which originally I copied from the To-Do app that I downloaded, and then I started to modify things heavily to work the way that I needed to. So it was a great template to start off with, and it helped me kind of hold on to the side of the pool before I was ready to dive into the deep end. But at some point, I was able to take it and run with it and not even need to look at that template anymore, which I think was kind of the intent here. So at any rate, let's get back to the story here. I created the application. I copied in the new path to my mobile service, and I also added the key that was assigned to me, and I was able to copy from... let's go back here, and I was able to manage keys, copy my key, my application key, and then put it into my JavaScript, and then I ran it. And the first time I ran it, it used that dynamic schema functionality where it created the contacts table because I referenced it in my JavaScript on the client, and it created 4 columns for me: contact name, speeding tickets, birth date, and pet owner. Now, for the most part, this looks pretty good. There's just one little problem here, is that the birth date is actually represented as a string. If I take a look at the columns, you can see that, first of all, speeding tickets is a string, and I may want that to be an integer so that I can perform math on it and things of that nature. And also, birth date is a string. So when you rely on dynamic schema, you may not get the fidelity control that you really want whenever you're creating your data store. So generally, it's a good idea to turn that off unless you really don't care. You're not going to perform any operations on this data. You're not going to do any date math or any numerical math on your fields of information that you're storing. However, I do care about that because I want to perhaps render this information differently. And so what I'm going to do is go back and actually delete this mobile service completely, and we'll start over again from scratch, and I'll show you kind of the whole operation here as we get started. Okay, so it's deleted now. I'll go ahead and recreate it. I'm going to use an existing database in the East US region where I know I have a database already set up for mobile services. And then I'm going to choose JavaScript as my backend and go to the next page in the wizard. I'm going to choose my MAMS MS SQL database and log in. Great. Okay, and after a few moments, it's ready to go. The first thing I'm going to do is go to the Data tab, and I'm going to add a table. I'm going to call this table Contacts because that's the table that I know I want to create that I've already used in my code right here. Okay. All right, and then once that's finished, then I'm going to go click into it, and then I'm going to select columns, and I'm going to create 4 columns in addition to the default ones that are already there. So the first column will be the contact name. Now, it will ignore your capitalization, so you don't even have to bother with that. Contact name. The next, I want to create a number and call that speeding tickets. And then I'll create another column, which will be a date called birth date. And then finally, I'm going to create whether this person is a pet owner or not. So true or false, pet owner. It's an odd collection of information to store about somebody, but it will suffice for this little simplistic example. So let's dismiss all of those, and I think I've got everything in place now. The next thing I'll need to do is to grab the new key that was generated for my application since I deleted it, and now I'll need to add it back in to my JavaScript. So here I'm in the page.js. Whenever we're creating a new instance of a mobile service client, you need to give it both the endpoint as well as this application key. And I pasted it in. And so let's go ahead and save that. All right, so when I run this the first time, there should be no data. So let's just make sure that we're good and fresh and cleaned out. Notice that I've already, again, I want to point out that, here, let's start back here. That here is the folder that I created. I copied in the index, the page.js, the styles.css, and I copied in this server folder from the to-do app that I created in the previous module. And the reason for that server app, folder is to double-click this launch Windows shortcut, which pops open the PowerShell script that runs Internet Information Services, or IIS Express, which you see in this window right here. Okay, so let's go ahead and minimize that, minimize that, and let's refresh what we have here. Okay, so we have no data. You can see the loading. It's taking a second to handshake with the database up online. Eventually, that should go away once it realizes there are no records, and it did go away. So it did the search, and as long as it was searching, it had that little loading message, and then that goes away. I probably need to style that up a little bit nicely. In fact, I need to add some more spacing and things of that nature. I'm not using the style.css that they used in their to-do example. I pretty much am ignoring that CSS. Instead, I'm using Bootstrap by Twitter to style this all up. So this is just a simple table. I'll show you it in a minute. These are an inline form, and so there's really nothing special here. You can go on Bootstrap's site and see examples of all these, of how I used this code and what it does for you if you want to pop this open and look at it on your own. At any rate, back to the matter at hand. So let's go ahead and try to create a new record here. We'll create another Bob record. We'll put the number of tickets that I've gotten in my life. I'm not even sure if that's right. I don't think I have any tickets, honestly. I'm a perfect citizen, as you might imagine. Okay, so, and then birth date, 12/7/1969. I'm a pet owner. I'll click Add. And now it's gone out and added that record to the data store. And not only that, I've been able to now retrieve the data back, and then I can render it the way that I want to. So a couple of things before I move on here I just want to point out. First of all, let's go back to mobile services, and let's see this data in our table. And I can see that this record now exists. I can select it, I can delete the record, and so on. We'll come back to this one more time in just a moment. Now let's take a moment and take a look at the code that I've written here. The flow is going to follow very closely to the to-do app because they are, it comes from that same origin, where I have one large function that's responsible for displaying the existing records from the database into that table that I have. And then the rest of the JavaScript is really responsible for the submit button when I want to add a new record. And I've simplified the JavaScript here so that if you're not a JavaScript pro, hopefully this is a little bit more readable than we could making it more compact, but also more complex to kind of break apart. So a few fine points here. Here we're creating a query, which is basically the entire context table. Now, I note here, like you can see in the To-Do app, I could filter this. I could say where the birth date is greater than a certain date or whatever the case might be, but I chose not to do that. You can go ahead and do that if you like. And then what I want to do is for each item that we read from this query, I'm going to perform this function. And this function has only one job, and that is to create a row in our table to display the content. You'll notice that I take two little departures here. The first one is to retrieve the birth date and to style it up correctly, and then to retrieve the pet owner field and to style it up correctly, because it may not, if it saves a null in the database or whatever, this will say, well, nulls are basically false. All right, so but the date is the challenge right here, because dates in JavaScript don't work quite like you might expect. And furthermore, dates in Azure Mobile Services have to work not just across JavaScript, but they have to work across C# and iOS and Android. And so the Azure Mobile Services team acknowledges this. So the challenge is that if you have a null date, if somebody doesn't type in a date and hit save, it's going to save the value January 1st, 1900, I believe. And you don't want it to save 1900. You know, that's not the true birth date. The birth date should be blank or null in that particular case, but that's not what's saved inside of the database. Furthermore, if you do get that date, then you want to format. If it's greater than, let's say, 1920, then we want to take that date and we want to format it. Let's see what happens if we don't format the date and we just do this instead. Birth date val equals contact dot birth date. All right, so we're not formatting the birth date, and let's see how that it looks in our example here. Okay, so it's kind of a little gangly. There's a couple of things to note. First of all, that I was born on December 7th, not December 6th. We can even see that December 7th is what's stored in the database. However, at some point in time, there's a translation that's made based on where my client is running, and I'm GMT minus 7 or 8. So it will subtract that, or I guess I'm GMT minus 6. So it subtracts that off of December 7th at midnight, and it comes up with December 6th at 1800 hours. So, you know, it's all wrong. It should be using UTC date instead of trying to do this calculation on its own. So when I ran into this, the formatting issue and the fact that it's not really handling dates the way that I would like it to, I went to this library, JavaScript library called moment.js, and it basically works with dates, and it gives you a nice little way to handle dates in your JavaScript, so that I could go and do, first of all, I created this moment object saying it's actually use UTC time, don't use whatever crazy date time that JavaScript's typically using, or Azure Mobile Services. I'm not sure who's responsible for that. But anyway, give me the UTC, and I want to format it in this style. So all in one line of code, I was able to make sure that it renders December 7th, not December 6th at 1800 hours, and that it formats the date the way that I want to see it on my page. So I would point you to moment.js. You can search for it online and find that library whenever you're working with dates. So now that we've worked with the date and a Boolean, and you can see even the number, it's simple because it's a simple conversion between from a number into displaying it on screen as a string. So I didn't have to do anything special for that. On our query of records that's returned from the server is that we're going to build up this list items collection. And so this list items collection is passed. It's going to contain all these rows, these TRs and TDs filled with all of our data, to a class called existing records. So let's find that item here in our HTML. The existing records ID, rather not class, ID is here on this T body inside of the table. So I've created a table and I've given it some bootstrap classes to make it styled up and look nicely. And then I have the caption, the T head, and so you see all that styled up nicely too, thanks to Bootstrap. And then I use the T body, and inside the T body we'll have the rows in the individual cells. All right. Now, as far as the inline form itself, you can see what I've done here with the form to make it look good and kind of all be nicely aligned. I'm using that form inline. Again, that's a class defined by Bootstrap. And then I use these form control classes, again, defined by Bootstrap. I use for that blue button, I'm using the BTN primary class, again, from Bootstrap, and so on. Okay. And I pretty much ignore style.css. So between the three of those, that's pretty much all I need to do. Let's see if there's anything else special here. No, I just add a script reference to moment.js and a script reference to the Bootstrap JavaScript file. Some of the functionality in Bootstrap requires JavaScript, so you got to add that in too. And then at the very top, obviously, I have a reference to Bootstrap linking a style sheet to the ASP.NET CDN Bootstrap min CSS. All right. And then I make a note here that Bootstrap would like to have some of these meta tags added in as well. So make sure you add those if you're going to do that. Okay, so there's one last thing that I want to show you how to do, and we're getting back actually to mobile services proper and not just this little application I built. Let's go over here to the script section, and I said that you can create triggers in JavaScript that will execute every time that either you insert, delete, update, or read a record. So each of those operations have their own JavaScript function that you can modify. Now in the most simple case, it's just going to take your request, whatever it was, and execute it. However, you can also do something a little bit more interesting by pulling off the particular piece of data and modifying it somehow before you allow it to go and be modified in the database, or inserted in this case into the database. So in this case, the item being passed in should be the record that's going to be inserted into the database. And to reference, for example, the contact name, I can just do something like this. And we'll append, and there's probably a nicer way with a built-in JavaScript function, but this is something that everybody can understand. I think it's simple here. So let's go ahead and save that. And we will just now try to run our application again. And this time we'll put Steve back in. This will be and I believe he's a pet owner. All right, and it took a moment, but it came back, and you can see that Mr. Steve has been appended to our to what was formerly just Steve. So I took the item, appended on a prefix, and then said go ahead now and execute it. So you can do a bunch of different interesting things here. You can modify the item that's being inserted, updated, deleted, or read. You can perform any checks. For example, this user object that's getting passed in, I can see, is this person authenticated currently? Do they have a role in our, we can create a permissions table. Do they have a role in the permissions table? And if they do, does that permission allow them to do an insert into this table? So you can create quite a bit of business functionality related to data storage here, or business logic related to data storage here on these little triggers. Also, I think we talked about this previously with the permissions, so I won't go into that just yet. And that's basically all that I wanted to talk about. You can use my example in conjunction to the to-do example, and maybe that will help you to design your own data storage mechanism on Azure Mobile Services. Okay, hopefully that gives you a little bit of an insight into how the data part of Azure Mobile Services work. Let's move on and look at another facet of it in the next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In the previous module, we used a JavaScript client library to insert and read records from our context table in our Azure Mobile Services data service. Now, while that's really cool, it's a little bit unsafe. I mean, do we really want just anybody canoodling around in our data? Well, probably not. We generally want to lock down data access, and there's ways to do that using the permissions tab, as we saw just a little bit ago here in the previous module, just by going here and then saying, okay, well, if you have to have either an application key to insert, or only authenticated users, or only scripts and admins should be able to do an insert operation. So that's one way to handle it. But what if the person does have permissions? Do we still want them to have just free reign over our data and be able to do anything they want with it? In some cases, yes. In some cases, no. Or how about a scenario where we want to perform some business logic or perform some operation on the server side? We want to check this or that. We want to write and read and update data. We want to send emails or notification toasts right from our Azure Mobile Service. We need something a bit more robust than just the triggers on the database tables for that we looked at in the previous module. So what we do is we turn to Azure Mobile Services Web API, And that allows us to hide implementation details behind a RESTful HTTP API that we create. The great thing about a RESTful HTTP API is that just about every platform will allow you to access it by either sending curl requests, or there might be some built-in library function like in .NET in order to accomplish that. So in this lesson, we're going to create a couple of web APIs, and I'm also going to demo how to test your APIs without having to write some sort of test harness in order to accomplish that. Actually, some very smart people have already done that for you, and I'll show you how to use it and use it with Azure Mobile Services specifically. All right, so what we're going to do is we'll use the same mobile service data example. Ideally, I would create a new one just for APIs. I'm going to go to the API tab. Now remember, this isn't the data and the API tabs are not available whenever you choose a C# backend for reasons that we talked about a couple of modules ago. And here we can create a new custom API, and I'm going to call this API something very simple. Just concatenate. All right. And we'll leave the permissions alone, but here again we can choose to apply the same permissions that we could when working with the data directly. We'll just go ahead, and anybody with an application key can call our concatenate function. I'm going to keep things very easy for the two examples that I'll give you, but I'm also going to point you to where you can find the full Node and Express API that you can call into all the objects that are available to you to work with inside of your JavaScript, whether you're creating the triggers or you're creating these web APIs. Okay, so it looks like we're ready to go in and edit it. You'll see that they give you some boilerplate code here that we can modify, and even some explanations on how to access various things like the tables so that we can get at data, or the push so that we can create notification toasts. So let's go ahead and just delete all that stuff out. And what I want to do is just take a very, very simple first pass at this. I'm just going to allow the user to pass in two values, value 1 and value 2. We'll simply concatenate them and pass them back. In fact, I think we can even, actually, we're not working, yeah, we don't need the get. So I'm just going to remove the get completely here in this example. So in other words, the only way that you can access the concatenate method on this web API is to post data to it. So in order to access the data that's coming in from the post, what we'll do is var value1 equals request.body. So that'll give us access to the form's body that's been submitted. And then we can simply access any of the name value pairs in that body. So if we have a value called value1 in the body, we can access it just by doing that, and we'll be able to get to it. Do the same thing for value 2. And I could write this a lot more succinctly, but I'm going to go ahead and just do this in a very obvious way. And then we'll just say that the message we'll return is not hello world, but rather value 1 plus value 2. All right. So it's as simple as that. I guess we need that. Okay, let's save that. Now the question is, how do we actually test to see if this works? Again, we could write some JavaScript code. We could try to kind of fumble our way through it and figure out how to get it to call. It might take us a little while to do that. But there's this great utility called Postman. I believe it started out, or it's available at least, as a Chrome plugin, but you can also get it as an independent application if you go to the Postman website. They also have a command line utility if you want to use the Postman service to do tests on web APIs, so you want to include it in your continuous integration strategy. And that tool is called Newman. Get it? Newman from Seinfeld. He was a postman. I thought that was kind of clever. Okay, so let's go ahead and pop open Postman, and you can see that I've got the desktop version running here in a little web window. I didn't upgrade and purchase the packaged application, but I plan to. It's only like $10, so it seems like a pretty good deal, and it supports these guys. So here's what we do. We actually construct our web API. You can see there's some remnants here from the last time I did this, and we're going to call our endpoint. So dataexample.azuremobile.net/API/concatenate strings. All right, it's already had that typed in. and I want to perform a post operation. You can see that I get all the HTTP verbs here and a little bit more. Furthermore, I can send in parameters. So we can do key value 1, and then we'll set that to Bob, and then value 2. So this is the form data that's going to get passed, and will represent the body dot value 1, body dot value 2 inside of the code that we just wrote. All right, and so for now, let's just do what we have here, and let's see what happens whenever we hit send. So it's sending out that request out to our web API. And you'll see that we get an error, 404 not found. That's probably because I didn't name this correctly. I think let's just concatenate. Now let's try it again. Now we get a different error, unauthorized, a 401 error. Now why are we unauthorized? Well, if you recall, let's go back here, you can see the permissions require that we send along an application key. Let's change this just briefly and say everybody can use this particular web API. You don't have to log in, you don't have to have an application key. It just will work for everybody. Just so we can see this working. And let's go back to, whoops, Postman. And let's just try that post one more time. And you'll notice that we get our two strings, Bob and Tabor, concatenated together. All right. Another thing I want to show you is how cool this little history, this collection is. So you can get back and look at previous runs and what you sent in order to kind of keep track of the things you tried and what worked and what didn't work. But let's say that we do want to, in fact, only allow people who have the application key embedded into their application to actually call this API. We don't want somebody just to, hack the API and then be able to call it from a different application and kind of spoof the fact that our application is requesting this service. So I changed back the post permission to anybody with the application key. And now let's go back and go to the dashboard. And let's manage keys, and I'm going to copy the application key and then close that window down. Now, what I need to do is I need to add a header. So I click the little header button here at the top of Postman, and this allows me to input, and you can see I already have this filled in from a previous session. So I was passing in XZoomo application. Okay, so this Zoomo header key is actually what they used to call Microsoft Azure Mobile Services prior to it being released. So it just kind of kept that code name of Zoomo. So we need to give it a value. Now the value that we gave it prior to this was from a previous run. I didn't give it the correct one, which should be the one that I'm pasting in right now. So let's go ahead and get rid of that one. And now let's try to run this again, this time using the correct application key. And we get satisfaction, our message is returning Bob Tabor. Great. All right, let's look at another example here. Let's pop open our portal and let's go to the API tab again. I'm going to create another API, and this time we're going to call this just write, or maybe insert contact, something like that. And we'll click OK. Now I'm only going to demonstrate posts, however this works obviously with all the verbs. So what you would do is basically, let's go into here. You would basically just use exports.get, exports.put, exports.delete, and so on in order to create the other verbs for your web API. Also, I almost forgot, this is the cool part. If you are a Node.js developer, do you see something similar to what that you would do to create a module, like any of the modules that you use, like Express, or it actually uses this module pattern where you add on a method to the exports object that your module is passed. So here we can attach on any method or object by just saying dot whatever equals blah, right? But in this case, Azure Mobile Services is looking specifically for some of these method names that match up with the HTTP verbs. So I thought that was neat. And pretty much anything you can do in Node, you can do here as well. I'm not sure if you can import other packages. I haven't tried that. You might be able to, because I think this is just a JavaScript file, so you might be able to do imports. But where would you upload the actual package to? Nah, I'm not sure. I'm not really worried about it. That might be something interesting to look into. Okay, so what if I wanted to allow people to insert, let's get rid of the get here, insert, but they have to insert records from our application using this web API where we do some value checking before we actually allow the insert into the database. In that particular case, what we'll do is we're going to create an item. And we'll go contact name and then request. See, that request object gets passed in the request and the response. So this is what comes in and the response is what goes out, just like in ASP.NET or any web technology. So request.body.contact name and then speeding tickets. And then we'll go request.body.speeding tickets. And then, so basically here we're just constructing a JavaScript object, a JSON message. So the next one, okay, let's just do that. Let's do those two. We won't go through the exercise of creating the entire thing. And let me end that there. And next up, let's get a reference to our table. So var tables equals request.service. Remember, that's how we get to some of the built-in objects that are available to us through Azure Mobile Services. So request.service.tables. So now we have the ability to get at a single table. Var contacts equals tables, and there's a method called getTable, and we pass it in the name of the table that we want, like so. And then finally, we'll do contacts.insert, and we'll pass in the item. All right. And then finally, what we'll do is just change up this message here. We could do something a little more elaborate, like pass back the item that was actually sent. In fact, that might be an interesting little experiment. Instead of just giving a hard-coded string, let's pass back the item and see what happens. See the sparks fly. I haven't tried this, so this should be an interesting little thought experiment. Okay, so now that we've created this insert contact method, let's go back to Postman and let's change some things up. We're going to leave the XSumo application header as is because we'll still need that. We're going to change this to contact name. Whoops, contact name, and we'll call this Conrad. And then how many tickets, so speeding tickets, and I don't think he's gotten any, but let's go ahead and give him 2. And then let's change up the API name. We're calling this insert contact, right? Isn't that the name of our API? Yep, it is. All right, what else do I need to do here? Contact name, speeding tickets, I think that should be it. So let's try and run this and see what happens. Okay, so we get the message back, contact name speeding tickets, like we anticipated. So we can see that our JSON object looks well formed. Now let's see if it actually inserted it into the database. All right, and interestingly enough, it does insert contact name and speeding tickets. Birth date and pet owner are null. Interesting, I spelled contact name wrong, and it put a connect name a new column in our database, and so it didn't put it where we want. So obviously this would be a problem. We'd want to change our web API. So let's go ahead and make that modification. So let's go ahead and make that modification. Let's go back to our API. Making mistakes sometimes is a good thing. It helps you get insights into how things actually work. Ideally, I wouldn't do them on camera, but no harm. Contact name. All right, so that should work correctly from that point on. Let's save that. Now, I have another interesting idea. What if we didn't have to construct that whole JSON object there? So the items that's coming in, what if it's already in the proper format? Let's test that thought. I'm going to comment that out and comment that out. And so instead of doing that, what we'll do is just var item equals whatever comes from the request. So request.body. That should work, I think. Let's see if that works. So we'll save it. Now let's go back to Postman. Let's change this up so there's a measurable difference here. And let's run it again. Okay, and interestingly, did you notice that even though I didn't construct the JSON message myself, that's what item is. That's what the body of the form is. It's represented as JSON here. So let's take a look now and see if it inserted the data correctly into the database. Grant, speeding tickets 1. So it works. It works the way that we thought it would. So that's great. Let me try this. I'm going to delete this record. So permanently delete the selected record. And then I'm going to go to columns and I'm going to delete that column, that extra column that was created, just to clean things up a little bit. So connect name, and let's delete that. Now here's one other thing that I want to point out too. If we're going to do searches based on birth date or some filtering on birth date, then we might want to set birth date as an index column. So just be apprised of that. It'll make our searches go faster. But that's pretty much all I wanted to say about the web API functionality of Azure Mobile Services. It's pretty cool. You can create simple, relatively simple, to moderately complex web APIs right inside of the tool. We don't have to like bail out to a whole other technology like C# or PHP or whatever you might, or Java or whatever you might usually use in order to create a web API. So that's all I wanted to say in this module. We'll pick it up with one more piece of the puzzle in the next module, and then we'll move on. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll look at the scheduler functionality in Azure Mobile Services. Let's go to the Scheduler tab, and we'll create a new scheduled job. And we'll just call it my first job. And we can schedule it to run every minute, hour, day, or month on a scheduled basis. And for now, I'm just going to go ahead and select on demand, and we can change the schedule at a future point once we get it created and we're comfortable with it that it's actually working. Okay, so now we can see that the status is disabled and it never is run, and the frequency is on demand. Now here again we can configure when we want it to actually to run. So I can change it here to every minute, hour, day, and week, month, I believe. Let's go on to the script portion because this is where the thing where the action happens, and it gives you a little boilerplate here of a function with the same name as the job itself. So that will get called whenever our schedule comes due and kicks off the script. And here we're accessing the console object, and this is just one of the many objects in the Azure Mobile Services API. So let's start there. why would you choose to schedule a job here as opposed to the other ways that we've looked at scheduling jobs? There's like a scheduler that's independent of everything. Then there's a web job scheduler that we've already talked about. And then there are, and even in cloud services, there is the worker role. We could use that to run a back-end process like we talked about. The reason why you would choose this is that if you're already using Azure Mobile Services, this scheduled job gives you access to the Azure Mobile Services API, and I already showed you this, or talked about it, but this is what I'm talking about. These are all the objects that I get access to. So you can see there's a console object, and we'll see what that does in just a moment. Then there's the MS SQL object that allows us to get to our tables. There's also the tables object, a specific table object, a user object. We've seen all these. There's the request and the response objects, and then some that we haven't seen, like push for notifications and things of that nature. So let's go ahead and get back here. Let's create a more, let's go ahead and run this service one time. And we'll see what happens whenever the console window actually is, or a method on the console object is actually invoked. Here we're calling the warn method, so I would expect to see a warning message somewhere. And if you go to the logs tab on the mobile service, you can see that it just added a new message here. You're running an empty scheduled job. Update the script for my first job, or disable the job. And you can see that there are a number of errors here from previous attempts where I had a mistake and I couldn't figure out how to fix it. So you can see what at least the difference between a warning and an error. And there's no way to clean this out manually. It just happens every 7 days. It'll clean out all of your old logs. So let's get back to our scheduler. And let's get back into my first job and do something a little more interesting. And all I really want to do is just prove that you can get at these objects in the mobile services JavaScript backend library. And remember, there's also one for the C# library if you want to use that instead, the C# version of the backend library. But in this case, let's go ahead and just get rid of this. And I'm going to get a reference to a table. So I'm going to go var contacts equals tables. Again, one of the objects that we can find here. Tables.getTable, we learned about that from the previous module, and we'll just pass in contacts, the name of the table that we want to work with. Not a value-added tax, a var. Okay. And then what we want to do is create an individual contact, and we'll just make a JavaScript object notation, or JavaScript object, a JSON string here, and we'll say contact name. We'll go Conrad, and then speeding tickets, and then we'll go 7. Now, actually, I made this a string. It doesn't need to be string. It needs to be an object, like so. All right, and then finally, we'll go contacts.insert contact, and that should work. All right, so let's save that. And now let's go and take a look at our data table, and let's see if Conrad's in there, and he is. We've added him back in. So that is how you work with the scheduler in Azure Mobile Services. It's different than the other schedulers or the other back-end scheduled jobs, because it gives you access to the Azure Mobile Services back-end library and all those objects that give you access to all the other pieces of Azure Mobile Services. Okay, so that pretty much wraps up everything I'm going to say about Azure Mobile Services. Clearly, there's a lot more that could be talked about. I'm going to leave it to other authors on Microsoft Virtual Academy to dive deeper into those topics. Moving on, we have now we're kind of winding things up. We need to talk about another dozen topics at a very high level. So there'll be just like these little 5-minute lessons that'll just explain a given technology, where it fits in, and why it's even there, and what are some of the features of it. And we'll begin that journey in the very next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure File Storage. Now, it's part of Azure Storage. We created storage accounts in the previous course, but we skipped Azure File Storage. Why did we do that? Well, a couple of reasons. The first reason is that unlike blobs, queues, and tables, storage doesn't really deal with data. It deals with more like files and file shares. And then the second reason we didn't talk about it is because it's currently in beta. And so you have to do some additional stuff to activate it. We'll talk about that here in just a moment. But basically, think of it as a big file share in the sky, in the cloud, that all of your virtual machines can access. In fact, I'm going to show you how I mapped a network drive to my Azure File Storage file share. And if you think about this in larger terms, like what does this really mean? When would I ever use this? Well, the beauty of this is that if your organization currently has a file share that it uses, maybe some applications needed, some processes that you got already in place need file shares, and you want to lift and shift your virtual machines and the applications that run on those virtual machines, they need a file share. What are they going to do? Well, now you have a solution for that. You can lift and shift your file share as well. And then everything should be happy. Okay? So getting started, it's a little tricky because everything's in beta and you don't have the beautiful interface like you have in the rest of the portal for the functionality. You got to use PowerShell. So it can be a little bit tricky. Some people I've read had problems. I had problems. You'll see kind of my trail as I figured this out. But at any rate, it starts by activating the preview feature. So you'll come to the URL that's on screen right now, and you'll scroll down, you'll find Azure File Storage, and you'll click the little try it button next to it. Now, I've already done that on my account, so it doesn't show up in my list here. In fact, this is a great way to enable all of the preview features of Azure if you want to check out the new stuff that's coming down the pipe. Okay, so once you've activated, then you can create a new storage account. And when you create new storage accounts, from this point on, you will have access to not only queues, blobs, and tables, but you'll also have access to an endpoint that puts you at files, the file service. And it can be accessed basically at the accountname.file.core.windows.net. All right, so once you've created that, the next step then is you're going to need to get into PowerShell in order to create a network share, create a folder in that share, upload files to that share from your local computer and things of that nature. So the first step is to install Azure PowerShell if you haven't already done so. And the way that you go about that is you go to this URL on screen right now, and you follow the steps here, but there is a caveat. You'll follow these steps, and then you'll get to the point where you have to connect to your subscription. And most people just use this newer method, just use the Azure Active Directory method. So you just type in add Azure account, and then you call get credential, and you save the credential off as a variable, and then you say add Azure account credential, and then pass in the credential. And that works, and you won't get any errors. It'll work just fine. But when you go to actually mount a share using PowerShell commandlets, it won't work. What you have to do instead is you have to use the certificate method. It's easy. Just follow the instructions. You basically type the get Azure Published Settings file. It pops you into your web browser. It goes to the web page, downloads the .published settings file. We've already talked about that in the previous 2 courses ago when we talked about Azure websites. And then you just import it back in to your PowerShell session, and all should be well. And they give you some examples of that here, of how that works. And at that point, you should be authenticated in PowerShell to your Azure account. So you can move on from there. And now what you need to do is go back to, or go to this URL that's on screen right now, and it's going to give you the instructions on how to actually, like I said, set up a share, a network share. So you'll kind of follow these instructions here till you get to create a context for the account and the key. So you give it the account name and the account key. In my case, the account name is going to be Bob's files right here, and then you're going to give it the key that you use from this manage access keys. You're going to copy in your secondary key or your primary key, whichever one you want to use, and you'll add that into PowerShell command line. Then you'll call new Azure Storage Share, giving the share a name. In my case, I just used exactly what they had here, sample share, and passing in the context that you created in the previous command. Now, you're either going to get an error message or you're going to have success. If you get an error message, it's probably because you did not authenticate correctly. Let me see where my PowerShell is here. There we are. Okay, and so you can see here at the very top, I had several failed attempts and got a little frustrated, and then like I had a aha moment. Maybe I need to actually, call import Azure published settings file, upload my published settings, and then once I tried it, I was good to go from that point on. And I was able to create a share called sample share, and then I created a directory in that share called my directory or my dir, and it confirmed that. And then the last thing that I did was that I uploaded a file from my local hard drive. I just had a text file called HD Insight, some notes for the HD Insight module, and I uploaded it to the my directory or the my dir path that I just created a moment ago. All right, so now that I've created the share, I've created a directory in the share, and I've uploaded a file to the share, the next step was to go and create a virtual machine and then load up PowerShell there. The first thing that I needed to do in PowerShell on the, let me get this up here, on the virtual machine was to call this command key, which tells this PowerShell, it authenticates it with my account up in Azure. And then I called this command net user, and I gave it the endpoint for my Azure file storage account / the share name, sample share, and then I think I did that wrong. Yes, net user, and I mapped it to the Z drive, as you can see right here. I did it correctly here in the second line. And so then I was able to pop open, here, let's get this a little bit higher. I was able to pop open Windows Explorer. I found my sample share. I was able to go in, look at my directory, and find the file that I uploaded. So it was a little tough going because, again, I'm a little shaky on PowerShell, and I hope to rectify that soon. However, it all works. I can vouch for it, and it just gives you an upgrade path from on-premise to the cloud if you need a file share. That's it. All right, so let's move on in the next module. We'll start looking at all the individual technologies at a very high level, and we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about HD Insight, and HD Insight is basically just Hadoop that's running on Azure. So you may have already heard about Hadoop before, and you know it has something to do with big data, and big data is basically just data that's collected from many different sources within an organization, or maybe even potentially with outside the organization. It could be semi-structured, it could be semi-related, but then you basically take all of this data that's just lying around and you start using it to gain insights, thus the name HD Insight, Hadoop Insight. And then you ultimately make more informed business decisions, at least that's ideally. So Hadoop, from a technical perspective, is really just two things. First of all, it's a massive file system that's built on top of commodity hardware that's all clustered together. So the file system has a specific format that assumes two things: that there's going to be hardware failures, and you'll want to swap those in and out, and so it's not going to lose data on you whenever one goes down. And then that there will also be hardware expansion whenever you need to grow the amount of storage and processing power because you're collecting more and more data over time. And so you can scale out to thousands of computers in a cluster. And there are entire books written about the file system portion of this. That file system is called HDFS. And it has that special sauce that knows how to manage the data and put it in the right spots and keep it healthy. But Hadoop is also this management service that runs on top of all those clustered commodity computers, and it manages how and where the data is stored, And it also manages how and where these little applications that you write will be distributed across all those computers. And the intent is to compile a set of data to give you answers to your questions, or at least you can start asking questions once you have some of this aggregated data. So Hadoop uses this programming model that's called MapReduce. You may have seen that term around. It's a programming model that really has two pieces, map and reduce. So you have map jobs and reduce jobs, and I call them mappers and reducers. So a mapper takes data in its raw format and it converts it into another set of data where individual elements are broken down into really small bits, just name value pairs. They're called tuples. And so the map job may go out and run on all of the data, potentially terabytes or petabytes of data, and it pulls out each little data point that it thinks is important and it puts it into a key value pair. Of course, you get to create these mappers using Java or C# or C++ or something along those lines. Also, there's a scripting language called Pig that you can use to do the same sort of thing. But the key is that these little mapper apps are distributed across all of the nodes in the cluster that have the data that we're actually looking for, and they're all running in parallel. So they're just responsible for their little neighborhood, their own little cluster of information. And so each of the little clusters, or each of the little result sets, I guess you could say, have preliminary answers to the questions that you want answered. Each mapper has data, but it's not aggregated yet. It's just kind of, you got all these little islands of data. So how do you collect them together and aggregate them? Well, that's the job of the reducer. So the reducer, or the reduce job, it takes the output from the mapper as input, and it combines all those little data tuples, those name value pairs, into a smaller set of tuples. So here you might be calculating a count, or the max, the min, the average, aggregate style operations on the data. And then once you have it at that point, you can analyze the data. You can see it at a very high level, and you can make some business decisions based on that once you've kind of processed all of these little data points. So I have a good example for you, or at least I think it's a good example. You might work for a large health services company, and this health services company owns hundreds of hospitals around the country, around the world, whatever the case might be. And your job is to determine how much you might save if you centralize janitorial services with a larger organization, a large outsourcer, instead of allowing each individual hospital manager to kind of hire a regional janitorial cleaning service. So one of the considerations of several that you want to take into account is patient infections that perhaps were due because of improperly cleaned facilities. So what you want to do is then export 3 years worth of patient data, so that you can see how many infections may have been due to inadequately cleaned facilities. So you have 3 years of patient data across hundreds of hospitals, and you want to ingest all of that into a Hadoop cluster, and then you want to begin writing mapper applications, whether in Java or C# or C++. You can do that in HD Insight, where that's not really the core functionality of Hadoop outside of Azure. And so those little mapper applications then are distributed across the cluster that stores all of your data to create those little name value pair tuples. So now you have several hundred results, each in a little silo, and you want to feed all of that into the reducer application that you create, that you might also write in Java or C# or C++ or Pig or whatever the case might be, in order to aggregate and analyze all that data to help create a cost-benefit analysis of infections due to poorly managed janitorial services. So hopefully that gives you an idea of how this all works. So Hadoop is open source, and there are many, many other Hadoop-related tools that are also open source that create this ecosphere of functionality. And so you would pick the parts that apply to your specific need. And I believe that Microsoft supports many of them. Here's the introduction to HD Insight. Let's take a look at that real quick, because they have a list of the ones that are supported. Yeah, here's a list of the of the components that they say are also included on HD Insight clusters. And they have a list there. It seems like most of these tools listed focus on ingesting data, cleaning up data, querying data, creating a workflow that orchestrates various operations on the data, and so on. But it all starts with creating a cluster and ingesting your data into Hadoop, and then writing map jobs and reduce jobs, and then running them against your data. And conceptually, that's pretty much it. That's about as far as I can take you. You know, when you create a new cluster here, it's the familiar interface on the Azure portal. You give the cluster a name, you choose how many nodes you want to start off with, and you can always grow that. And then you'll create a username, password, and a storage account where you want to actually store all of the data itself. Okay, so that's as far as I can take you with this. There is a wealth of instructional content on Hadoop and HD Insight, on MSDN, on Azure's own documentation, and then of course on Microsoft Virtual Academy. And I know that there was a lot of big data marketing buzz a few years ago and a lot of demand for Hadoop. I know that people with Hadoop skills were in high demand, so if you're looking for a way to reinvent your skill set, this might be a good path to go down. All right, so in the next module, we're going to look at another technology that has a similar goal, but goes about it a little bit differently. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure Machine Learning, which promises to bring data science to non-data scientists. So you can do things like analyze and find correlations in large sets of data so that you can use that in the future to make decisions on the spot. So at the highest level, you start with some large data set and a question in mind. Let's say you have several columns of data, age, gender, occupation, amount of school completed, and salary. And so in the future, you want to predict somebody's salary based on that other data. Which combinations of the data, what are the factors that play into salary, and so you want to be able to give some level of prediction to some degree of statistical accuracy as to kind of find how much this person can afford, what their salary range is. So then what you could do is you can create a scoring model, and then that models your algorithms that you're using to analyze the data. And then once you have it figured out and you've got your model in place, and you're saying this well represents the data set that I'm working with, then you could go off and create a web service based on that model that you created. And now exposing that web service, just like any other web service from a software development perspective, you can collect a few data points, send them to the web service, and it will send you back a dollar number, how much you could expect the salary range for that individual. Pretty cool. Okay, so you can see them in the Azure portal. You basically start by creating a new machine learning workspace. You can give it a name and give it a storage account and things of that nature. You can see that I've already created one here, so let's just drill into that. And here on the dashboard, you can see that there are familiar things like that allow you to monitor and then configure some aspects. But really the magic happens when you click this Open Studio button at the bottom. It opens up the Azure Machine Learning Studio. And here's where you create experiments using modules. So the idea here, let's go ahead and open up this experiment that I created. What you do is you drag modules to the experiment canvas, this area in the middle here, and then you connect modules with lines that kind of represent data flow. And they create this data science workflow. So you configure the modules, then when you select it, you can configure it with the property pane over here on the right-hand side. So as you can see here, we basically are using a data set called the Adult Census Income Binary something or other here. Let's see what that is. Classification data set. And you can view the data set and it'll show you in CSV. Let's go ahead and open up in Excel just for fun. Okay, and you can see that there's several points of data and there's thousands of rows. I forget exactly how much, but basically give us the classification of work that they do, their level of education, marital status, their race, their gender, and things of that nature, not the least of which is their income range. So now what we do is we clean up the data. So if there's any missing data in that data set, if it's like an empty field, then we want to set that to 0. And then we want to say we're only going to use these specific columns. We're going to ignore these other columns as we analyze the data. So we can use a project columns module that we dragged and dropped from our modules here on the left-hand side. Now, I've already created a scoring experiment, but when I was developing this, what I did was created a split and took some of the data and ran it against the various algorithms that are available here. And this is where some knowledge of data science would really come in handy, because I really don't know the difference between a multi-class decision forest and a multi-class decision jungle. But if you do select one, you can always click more help, and there's some articles on MSDN that explain at a high level. And you would just want to go through and think about the attributes of each and which one makes sense in your particular scenario. But essentially, let's back up and talk about this from a very high level. You are creating an experiment to predict whether an individual's income exceeds $50,000 a year. And you want to use a sample data set, or you can connect up a reader, which is pulling data from like a SQL Server database or something along those lines. Then you do some pre-processing like we do here. And what's not depicted here is the split. And you would split that data set into 2 parts. You create a training set of data and a test set of data. So the training set of data is used for training and learning the algorithm. And so it's going to look for correlations and the likelihood that the outcome is statistically accurate. And there are a bunch of learning algorithms here, like we looked at a moment ago. And then you attach both of those splits to the score model. And what that'll do is take the test data and run it through the score model. And that runs the data through the algorithm, and it performs a prediction. And so you can click the run on the toolbar here, and that kind of kicks off the whole process. And once you do that, you can actually save the data set, or you can export the data set. You can either save the data set, or you can visualize the data. So once you have the results, you can view them in the studio, and it gives you some limited viewing options. I don't even know if I can get to that at this point, because I'm a little further along than I wanted to be here in this. But you might prefer to export the output data to Excel and create some more interesting visualizations. And then you might create several models until you find one that you feel most accurately represents or finds the answers to the questions that you're looking for. And then the cool part is that you can create a scoring experiment like I've done here already, which adds a web service. So you can see here that I have a web service input and a web service output here at the bottom. And it optimizes the experiment for ongoing scoring of data. So once you publish the web service, then you can utilize that web service and call it from any number of programming languages, anything that can hit a RESTful HTTP API. And so conceptually, that's what machine learning is all about. And I'm really excited about this. I'm not really sure how I'm going to use this in the future, but it seems like this is something that I should know, that it unlocks insights that even large companies have been able to get before now. Okay, so conceptually, hopefully that makes sense. Let's continue on as we look at this last high-level overview of Azure technologies. We'll see you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure Recovery Services, also known as Azure Site Recovery. And basically just think of Azure Site Recovery as a backup service in the cloud. Essentially what it does is a cloud-based service that will work with your own on-premise virtual machines to create a second data center that will be used to fail over if your first data center goes down for any reason. So the Azure Site Recovery software has to manage copies of data over to either another second on-premise site somewhere geographically different than your first data center, or up in the cloud. Now you might be wondering why a whole data center might go down, but I worked at at a company before I started my own company, LearnVisualStudio.net, and basically there was some road construction going on near our office, and a backhoe dug a hole, broke the fiber optic cables, and our company was without internet and electricity too, I think, for a whole day or two. So those sorts of things can happen. What happens to your company if your data center goes down? Well, hopefully you have failover for all the other regions that are relying on that corporate data. They can hit either your virtual machines that have been copied on an ongoing basis to, in the cloud in Azure, or at a second location. So basically, site recovery handles many of the pieces of the puzzle to coordinate this whole thing. First of all, it coordinates, automates, manages ongoing replication of the data and any applications from a virtual machine on the primary site to the backup site. And then it's going to monitor the health of that primary site, and if it goes down, obviously it's going to go into a failover scenario. But then you can also create customized plans, and because sometimes there are interdependencies between applications, and one set of servers needs to be up and running before you start another set of servers. You can customize a recovery plan to accommodate that. And let me just walk through the basics of setup. I mean, we can just look at the Azure portal. The problem is I don't have a Hyper-V manager set up here in my local office. That's kind of a core piece of the puzzle, so I can't really go much further than just creating a new vault here. But essentially, the first step is to create a new vault, and the vault is where you're going to store the virtual machines that are under protection. You're going to apply protection settings to the collections of virtual machines, and all that data is going to be stored in a vault. And then you're going to have the opportunity to download and install two applications on the Hyper-V server. The first one is called the Azure Site Recovery Provider, and that's going to handle the communication between site recovery and Hyper-V and your on-premise to perform that communication orchestration that we've talked about already. And then the second thing you'll need to install is something called the Azure Site Recovery Services Agent, and this is what is handling the ongoing transport of data, the copying of data from your live primary data center to the virtual machines, either on the cloud or in another place. And then you'll create a storage account, and okay, the next thing kind of depends on whether you're going to save into the cloud or you're going to save onto an on-premise location. But if you're saving to the cloud, you're going to have to create a storage account where all the backup virtual machines and data will be stored. And then you'll create a protection group around the virtual machine so that you can apply settings at a global basis. So you don't have to use the same security settings or the recovery settings on each individual virtual machine one at a time. You can kind of just group them together. And then finally, what site recovery allows you to do is to test the deployment to make sure that when it all goes down, that this strategy will actually work. So it allows you to do this in an isolated network, like it says in the slide, so that you're not affecting your production environment. Now, we've talked about backup strategies, replication strategies before throughout this series many times. What makes this different than the other forms of replication that we've seen up to now? Well, the first thing is that this focuses specifically on on-premise backup. Again, most of the backups and replication scenarios up to this point have been services inside of Azure. But what about services that are outside of Azure or your virtual machines that are outside of Azure? This allows you to protect them too, but backing up to Azure. And then the second thing I would say is that this focuses on disaster recovery as opposed to maybe replicating for the sake of speed, for for routing requests from certain parts of the world to the closest provider. No, this is disaster recovery. So if an entire data center goes down, then you'll be protected. Okay, so that's all I really wanted to say. Again, to go any further into the portal would require that I have some things set up locally here, and I just don't. But you can obviously find out a lot more about this in Azure's own documentation, and I believe there's also some courses about it on Microsoft Virtual Academy, of course. All right, so let's continue on in the next module, and we'll keep learning all these additional technologies. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure Store Simple, which is a company that was purchased by Microsoft a little bit ago. And they basically created hardware and services that allow you to seamlessly extend your data storage from on-premise out into the cloud. And so Store Simple makes an important distinction between two types of data. There's active or hot data, and then there's cold data. And it is exactly what it sounds like. Your active data are Tier 1 style applications like your CRM system and your ERP system, anything that's requiring instant access. Maybe there are files that are frequently used by your staff. But then there's also cold data. This is like from Tier 2 applications, archive data, where some latency is okay. You wouldn't expect to just be able to maybe get to it in a fraction of a second. You'd be willing to wait, I don't know, 3, 4, 5 seconds, maybe 10, 15 seconds for that particular data because it's not as frequently accessed. Well, what Store Simple does is that it creates this the hardware device that you can buy and cluster together that provides storage, and so that storage is used locally for the active data and also for cold data, but at some point as you start reaching capacity on those appliances, it'll start pushing some of that cold data out to the cloud. So this is called automatic storage tiering. It looks at how often certain data is being used, how old the data is, what its relationship is to other data that is stored on your file systems and so on. And so again, Store Simple sells devices, basically computers with a little special sauce on it, the Store Simple software that sit on premise and they communicate through the cloud, and they throw Tier 2 and snapshots of Tier 1 into the cloud. When I say a snapshot of Tier 1, occasionally it will take everything that's on premise and put it in the cloud for disaster recovery purposes. So what it will do is that it monitors how much available space there is locally through a process called thin provisioning. It will make sure there's always enough for the immediate need, whether it be today or whatever the case might be, based on previous usage. And then it will push data to the cloud as needed. And this basically is an effort to optimize the space required on premise. It will also perform other operations to ensure that you're using your on-premise file systems as optimally as possible. It'll perform deduplication and compression on files that sit on those Store Simple devices. Specifically talking about moving that Tier 2 data out into the cloud, what it will do is it'll make it look like it's seamless, like it's still on your local file system on premise, even though the files are stored in the cloud. There's that latency that we're talking about. What it'll do is take a snapshot of all the files that are in the cloud and present them as if they're files that are available, on premise, so you don't really see where the files are stored. And then when you say, yeah, I need that file, it'll go out, pull that file down, and make it available to one of your users. And then also, as I mentioned a moment ago, it'll store snapshots of Tier 1 data in the cloud in order to enable disaster recovery scenarios. And so disaster recovery is kind of a challenge too. I mean, when you have terabytes or even petabytes of information, how do you restore that in a very timely manner so that everybody's up and running again? Somebody said you might think it only takes a couple of days to get all your data back, but it could take, honestly, could take weeks to get the data back in place and make it available again. So Store Simple does something that's pretty neat. It treats that, in that scenario, it treats the Tier 1 data just like the Tier 2 data. It gives you a snapshot of what it has stored up in the cloud, and then when you need something, it'll go pull it down on an as-needed basis until it is fully back and replicated so that the Tier 1 data is in its home on premise. And that's pretty much all I have to say about Store Simple. I obviously don't have a Store Simple device of my own to show you, but at a high level, that's what it will do for you. So let's move on to the next technology in the next module. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure Media Services, and it essentially allows you to do 4 different things. First of all, transcoding and encoding, live streaming so that you can have your own little web broadcast, your little web TV show, like Twitch TV, for example, would be a good example of live streaming. Rights management to ensure that movies from content providers are not ripped or stolen from the stream, at least. And then finally, content indexing, where it will actually listen and create text from the speech in the video for the purpose of closed captioning or whatever the case might be. So let's take a look at these just a tiny bit closer. Why would you ever need to encode a video? Well, you know, the videos that I create here, you have to encode them from their original lossless format into something that's smaller so that it can be adequately transferred over the internet. You can't transfer the lossless version because literally they are gigabytes and gigabytes for just, you know, a 10 or 15-minute video, especially if you're working in high def. So typically what you do is once you get your source complete and you've edited it and you've got a master, you would then encode it, and that takes a lot of processing power. And instead of buying computers to do that, if you have a lot of content to encode, then you can just instead upload it or send them a hard drive or some sort of media that has your content on it, and then you can encode it, transcode it in such a way that it will be available, for example, in multi-bit rate, so that somebody with a small screen will only get a few of the bytes, not all the bytes, whereas somebody with a large screen, a lot of bandwidth, would get more data sent to it. Okay, so that's what a multi-bit rate MP4 will do for you. And there's two different tools that they offer. One is obviously more expensive. The Azure Media Encoder will take a few file types and will output in a few file types, mostly the popular ones. Now, if you have a lot of different types of content that you need to encode, you'd want to use the Media Encoder Premium Workflow, which it's like every type of video or audio file known to man. It'll import it and export it into those formats. So that's usually called transcoding as well. And so yes, you use Premium Workflow to transcode to and from virtually any file format. It also supports transcoding closed captioning files. So there are certain files that have the full text and time markers, and to sync those two up, you'll need special software to do that, and Premium Workflow has those tools. Also, you know, almost everything we talk about in Azure can be automated, and this is no exception. The other feature that's available through media services is live streaming. So like we said, like a webcast. Also, they tout the Olympics, the previous Olympics being broadcast in its entirety through NBC using Azure Media Services. So it can handle the traffic, it can handle the vast amount of content that's produced as well. And so essentially you, unlike encoding a video in the cloud, you would need to encode locally and then upload that to the cloud so that it can broadcast that and transmit it to all the clients. And so on the server side, there's software called Live Encoder, but on the client side, there are programs like Wirecast from Telestream, who make an awesome video editing product as well called ScreenFlow, which I have used for years, and all the way to high-end encoders that are tens, if not hundreds of thousands of dollars. Excuse me. And they would be encoding on the client and uploading to the live encoder up in the sky. So the other thing that you can do with live streaming is that you can have all those streams delivered via the Azure CDN, so that a client request coming in will get the stream from the closest point geographically. And the live encoder will also package the stream that's appropriate, whether it be for iPhone, Android, Windows Phone, Windows Tablet, desktop, whatever the case might be, whatever the client player is, it can adapt to that. Then there's rights management. You've heard this as DRM, Digital Rights Management. This service is also known as Azure Media Services Content Protection Services. Quite a name. But essentially it utilizes Microsoft's existing investments in a technology called Play Ready, which is approved by most of the motion picture industry's standards to ensure that streams don't get ripped. So there are programs out there that can, like for example on YouTube, this is probably the best example. YouTube is sending content down to a client player in a web browser. There are programs out there that can rip the stream, so they kind of get in between the communication and any of the video data that comes down. They can scrape it off and then save it locally on the hard drive. And they can also, peek at where the actual files are being stored, or the actual location of the files, and then they don't even have to go through the YouTube client anymore. They can just kind of put that on their own website without any using their own player, without really using YouTube. Now, I think YouTube's locked all that stuff down. I don't think you can do any of that anymore, but that's essentially what PlayReady will do for you. It encrypts the stream so it can't be ripped, so that you can't just take the file location and embed it on your own website and things of that nature. And then finally, content indexing, what I mentioned earlier, where it will actually listen to the content and create closed captioning files as a result of that. And not only that, will it create the speech to text, but then it will also index that text so that you can create like a searchable index. So if somebody's looking for a particular topic, they can search through all the video by looking at the associated text that was created from the video. Really cool. And that's pretty much all I have to say about media services. So let's continue on in the very next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Service Bus, Azure Service Bus. If I had one regret in the series, that I didn't spend more time on this. I think it's important maybe to think about Service Bus conceptually. It's cloud-based messaging. Oh, you're saying, well, okay, we've already got cloud-based messaging. We have queues, right? Yes, yeah, we do, but Service Bus gives you many more options. And you can think of it kind of, I give you three analogies for the different ways that Service Bus can be used. First of all, there's like a post office in the real world where one person puts a message in a mailbox and walks away. The postman, he comes and he grabs the message, takes it, they route it to somebody else's mailbox. They come out to get their mail several hours later and they get the message. So this is a brokered situation where the post office is brokering messages. Both the sender and receiver don't have to be standing at the mailbox at the time when the message is being delivered. So that's one scenario that can be kind of, if you think about that electronically, can be enabled. That's very much like the queues, the Azure Storage queues that we've already talked about. But then there's also the ability to use it like the phone company, where it's not brokered, where two recipients and two senders and receivers are talking to each other essentially in real time. And you need some messaging mechanism that allows them to send messages and receive messages bidirectionally, and so that's more like the phone company. And then finally, Service Bus can be used kind of like a voting booth, right, where you have many people coming and dropping messages in, whether it be their ballots, right? They're filling out their ballots, they're putting them in a box, filling out a ballot, put it in the box, and then the box gets full, right? And then somebody can take and process all those ballots. So Service Bus can accomplish that. So let's put some terminology to these analogies that I just laid out there for you. There are Service Bus queues that are analogous to Azure storage queues. Essentially, that one-way messaging scenario, the post office scenario that I laid out there just a moment ago. Each message received by a single recipient, it's brokered. Neither system has to be online at the time when the message is delivered, that sort of thing. And you might ask, well, how is that different than Azure Storage Queues? And it's just, you're going to have to trust me that it's a little bit more robust than storage queues. Then there's also topics, and this is it's one-way messaging, but using subscriptions. So I'm not even sure what a good analogy for this would be, but essentially these subscribers are waiting to listen for messages on a queue, and whether or not the recipients choose to actually listen to that message or not depends on a filter. So each of the recipients may be listening for different types of things, but the message will get delivered to all of them. So you create a filter where like the date has to be greater than such a date, or some value has to be less than such and such value. And if it is, then I'm interested in that and I'll process it. Okay, so that's topics. Also brokered. The sender doesn't have to be running at the exact same time the receiver is. You got a great decoupling of a system that way. Then there are relays, and that's that bidirectional messaging. This is not brokered, so both systems have to be online at the same time. Just Service Bus, it's like a bus, any kind of bus inside of like on a motherboard or whatever the case might be, where it is facilitating the messaging system between two systems. And then finally, we have what I call the voting booth, event hubs, where you get a high volume of messages that are being ingested from potentially many different sources. So in this particular case, it's not a voting booth, it's Internet of Things, it's reporting systems from sensors on various machinery, or messages that are being sent by many different application users, maybe on their mobile phone or their tablet or their PC, but all of those messages getting fed to one big barrel that can be processed then. Service Bus allows all these types of communication. And so that's all I can really say about Service Bus at a very high level. And any more than this, we would need to get into some code examples, and this is where the regret comes that I didn't have more time to talk about it. But I know that this technology has been around for a while, so there are many great resources on Microsoft Virtual Academy that will go through these in more detail. All right, so let's keep moving on quickly to the next topic. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about BizTalk services. Now, BizTalk's been around for, at least 15 years. I remember going to some training in Los Angeles once to learn about BizTalk in another life, it feels like. But at any rate, BizTalk services is basically BizTalk in the cloud. And what is BizTalk? Well, think that you're trying to integrate two systems that were never intended to talk to each other, and you needed to get them to talk to each other as quickly as possible. Well, you could write a lot of custom code, or you could employ BizTalk and allow it to integrate between these two systems. I believe it's called like enterprise application integration, making two systems work together, never intended to work together. So let me give you a good example. You have a partnership between two companies. You've got an order taker, some front end company that has a strong brand image, and then behind the scenes they're outsourcing fulfillment to another company that's kind of behind the scenes. And how are these two companies going to commute with each other? When a new order comes in, how do we push it then to that other company? There's a billion different ways to do that. But what if one company, the order taker, has some really old mainframe system to take orders, and the fulfillment company has the latest technology that it uses to actually fulfill orders? So you could spend a lot of time, again, writing custom code to make that, to glue those two systems together, or you could just employ BizTalk. And so BizTalk will do more things than just take a message and pass it along. It'll perform transformations on the data, so it'll take the output from one system, it'll clean it up, it'll reformat it so that it can be ingested easily into the other system. And it can be also used for orchestration. So first do this, grab the file, clean it up, do this other process on it, upload it via FTP to another server. And I think it can also accommodate two-way communication as well. I'm just kind of talking about one-way communication up to this point in my slides. However, it also has the capability of enabling electronic data interchange, which is a standard, or rather a set of standards around exchanging data for specific industries. So I think there's like, I don't know, I'm going to guess 30 different specifications or so. For example, if you're in the agriculture business and you want to send data between two systems, well, there's a set format defined for interchange of agriculture information versus automotive information and things of that nature. And so basically at a very high level, BizTalk Services knows how to connect a lot of enterprisey systems together and to make them work. And that's really, in a nutshell, what BizTalk Services is. And I'm not going to go into it any more than that. Maybe you can find some use for it in your organization. But let's continue our whirlwind tour of other Azure services in the next module. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll talk about Azure automation. And simply put, Azure automation is just the ability to schedule and manage PowerShell scripts for various tasks inside of Azure to automate some aspect of Azure. And so you essentially create these scripts, which are called runbooks, and you can then add these runbooks to your collection and schedule them and name them, and then they'll run periodically as you need them to. Now the cool thing is that there's this whole gallery of runbooks that are available. So let's actually open up. And you can see that I've created an automation account. I've got one account here, and let's go ahead and dig into it. And one of the things that I can do is import runbooks from the gallery. And here is a list of the runbooks, kind of divided up by what their tasks kind of entail. Let's take a look, for example, at, so I had a backup one here a minute ago. Yeah, let's go back up an Azure VM using Microsoft Azure Automation. Great. All right, so say that I wanted to use this particular one. Let's get down here. Unfortunately, this does not want to cooperate with a small screen. So we'll go to the next page of the dialog, and here you can actually take a look at the runbook itself. It's just PowerShell, and you will be able to read the description. It may have dependencies on other PowerShell scripts, or runbooks rather. It may give pointers to more information about this particular runbook. Notice that each of the runbooks are licensed by the owner of the runbook. So these are, in some cases, community contributed. And now say that, yeah, I'm comfortable with this and this is what I want to use. I'm going to call this Bob's Backup Azure VM in my automation account. And let's go ahead and say create it. And now that I've imported that, I can take a look at my runbooks, and I can schedule the runbook to run. And this says that you have to publish the runbook before you can add a schedule. So we'd have to come over, and after we've modified it, we'd have to publish it to make it enabled, and then we can begin to schedule it and things of that nature. I think it's set on the author page here. Yeah, so here we would run it in test mode, and then eventually we would, you see this little icon down here at the bottom. We would publish that runbook and make it available, at which point then we can schedule it, and then we can see how it ran, whether it was successful or unsuccessful on an ongoing basis. And just one other thing to point out is that one of the things, the features of runbooks is that you can establish checkpoints to resume workflow after a crash. After the PowerShell script creators, you can then resume the workflow. So there might be several steps. You don't want it to just end right in the middle. You want it to continue on, and so you can create checkpoints that allow that to happen. Okay, so that's all I'm going to say about Azure Automation, and we're getting near the end. Hang in there. See you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, we'll take a look at Azure Scheduler. Essentially, you can schedule stuff. You can define the frequency, the interval between times you want it to run. You can create a prescribed schedule. You can say, I only want it to run this many times. You can say, I want it to run until this particular time, then stop. So you have a lot of scheduling options. Now, what can you schedule? There's really two types of jobs. There's an HTTP job and then a message queue job. So you can either put things on the message queue on an automated basis, or you can call out to some RESTful HTTP API. And so it makes it perfect for doing things on inside of Azure, since almost everything in Azure has an endpoint in the Azure Management API. And you've been using this before in this series. We just didn't talk about it in those terms. It's actually what powers Azure Web Jobs and Azure Mobile Services Scheduler behind the scenes. And so if you take a look, I haven't done anything special here, but I already had a job collection created. And a job collection just has a series of jobs associated with it, and they're all kind of run as one unit. Now in this case, I think these are all web jobs running on the same account. And you can see that here are, for example, the hero versus robot hourly update web job that I created. You can drill into it. You can change the parameters, how it's actually kicked off. Now notice I didn't set anything up. This was set up for us whenever we created this web job in 2 courses ago. But this is how it calls the API and to trigger the web job to get to actually start. But you can also add basic authentication. You can give it a schedule and things of that nature. And these were things that we set up again on the web job. They were just transferred here to the scheduler. You can also take a look at the history. You're going to find any errors that you had experienced. What did it attempt to do? How many times did it try to do it, and things of that nature. And then obviously you can see whether it's in total, did the collection of jobs, are they failing or are they succeeding? And you can drill into that on an ad hoc basis. Also, there's this ability to scale. So as you can see in the free plan, I can have 5 jobs. However, if I were to upgrade to standard or premium, I would get more than that to work with. And that's pretty much it with Azure Scheduler. You've been using it. It's basically you're able to call out to an HTTP API, or you're able to put something in a message queue, and that is pretty much it. And you're also able to define what happens if the job fails. You can create a retry policy. I didn't really show that. Okay, so that's all I wanted to say about Azure Scheduler. Almost done. See you in the next module. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net. In this module, the final module, we'll talk about API management. And essentially, API management allows you to wrap your web API, regardless of where it's created and what technology you use to create it, with several features that allow you then to offer this to developers that they can use. Maybe those developers are inside your organization. More likely, they're outside your organization. So just about every web application out there offers an API as a way of allowing developers to integrate their service with their applications and hopefully bring more customers in. So there's a Facebook API, Twitter API. All of these applications have created APIs. And so how do you manage that? If you wanted to create a service that you want other people to use, well, here's what you would use to manage it. You could write your own services that are provided here, or you can just use what Microsoft's already created. So you can wrap your API, web API with security credentials, whether it's just basic authentication all the way up to using OAuth 2.0 or certificates. You can create usage quotas and policies, like you can limit how many calls a particular developer can make, or how many calls in a certain period of time. Or just how many calls in general. Maybe over the course of a month you can only make 100,000 calls to this web API, or you'll have to pay a premium for that. There's also the ability to provision new accounts, so allowing new developers to come in and utilize your web API. You can also terminate old accounts. You can send out email notifications letting people know, or the administrator know, that a particular subscription has hit its quota limit, like we talked about in the previous point. You can troubleshoot using tracing tools, very much like Postman that we looked at earlier, allowing you to send messages in and see what the communication is back and forth between some client front end and the back end web service. There's also disaster recovery built in, so that if you're using Azure and your web API goes down, it can be brought back up in a different region. And then finally, it allows you to deploy to multiple Azure regions to reduce latency, geo-latency. So again, this is the scenario where Europeans would hit, maybe the West Europe data center, where people in Texas would hit the East US data center. And that's essentially Azure API management. Let's take a look at where it's at. We're not going to get too deep into it, but essentially it's right beneath the scheduler here in the current version of the portal. And you can see I created an API management account already just to look at it. Here I'm able to configure this web API, but this isn't so interesting. You really need to look at the publisher portal in order to create new endpoints for your APIs, to look at the various policies and analytics and things of that nature. So I think this should, yeah, there we go. It needed to be a little bit larger for the screen, but essentially you can see a aesthetically pleasing dashboard. You can look at all the APIs that you've already created. You can wrap APIs into products. A product, for example, to give you two examples here, there's a starter where it only lets somebody call for development purposes, and then there's like maybe an unlimited package which allows unlimited API calls to your API from your customers. Again, setting up the policies. This can only be this product level can only support so many calls. Otherwise, they have to upgrade to another package, and pretty much the other things that we've looked at previously, or we talked about in some of the bullet points. This is one of those services that you'll definitely want to dive in deeper to if you ever need to publish a web API. And again, there's courses on Microsoft Virtual Academy that talk about this in more depth. But at a high level, if you ever need to offer a web API outside of your organization to bring in and attract developers to your platform, or just to provide some service that you want to charge for, maybe a zip code lookup given an address, for example, then you could use API management to accomplish those things. Okay, so let's continue on in the final module where I say goodbye. We'll see you there. Thank you. We did it! We did it. This is a special occasion. It's not every day that you finish watching an entire series of courses comprising 101 lectures. So it's cause for celebration. Now, I wanted to wear a tuxedo and pop a cork on a champagne bottle to congratulate us both on this accomplishment that we've made it through this series. In lieu of champagne, I welcome you to eat a victory cookie with me. This series took twice as long as I thought it was going to take to record, to prepare. And honestly, I still feel like there's so much left for me to learn and so much left that I could teach and tell you about. As I've said many times up to this point, Azure is so large and it continues to expand at such a rapid pace that it's hard to keep up with all the new developments. And while it's daunting, it's also a pretty cool time to be a software developer. I mean, we're doing things that have never been tried before, so that is cool. And I want to take a minute here at the very end to thank a few people who stay behind the scenes and allow the instructors who teach on Microsoft Virtual Academy to provide quality training to you for free. And I hope I pronounce all their names correctly. I've communicated with them via email for many months, but I haven't really talked to them personally and heard their name pronounced, so please forgive me if I mispronounce their name. But Colin Leith, Pete Harris, Jonathan Sanito, and Jeff Koch. I'm pretty sure there are others that I've never had direct contact with who are also working to help deliver this training material to you. And despite repeatedly missing deadlines, they treated me with kindness and respect and encouragement, and I appreciate their good work. Thank you, and the development community thanks you as well. And finally, I want to thank you, the vigilant viewer of these series of courses. You know a vast number of people who start a course, never finish it, but that's not you. You did it. Awesome. And Microsoft Virtual Academy is all about you, your learning path, your career, helping you acquire the skills that you need by giving you access to the best qualified instructors that are available for free. And so now it's really up to you to get out there and show the world what you can do and demonstrate your professionalism and your knowledge and be so good that they just can't ignore you. Now let me make one final plug for my own personal website where I do training on topics related to C#, .NET, ASP.NET, things of that nature. www.learnvisualstudio.net. Hopefully I've branded that in your mind by now. And my goal on this site is to help developers get their first programming job or build their first application of consequence. So at least check it out and come visit me there. And I teach by forcing people to actually write code through many coding exercises and awarding you achievements as you accomplish each task. So again, please check it out. Now, on a personal note, I'd like to hear from you if you have actually finished this whole series of courses. I love hearing that. It motivates me to continue on doing this sort of thing. And the best way to get in touch with me is through Twitter, @BobTabor. I'd love to congratulate you personally on your hard work. Now, I want to commend you in your perseverance and encourage you to keep growing little by little every day. Constant, steady improvement every single day. As a developer or a technology professional, your primary job is really to become a professional student first, That's what makes you valuable. Applying your knowledge to business problems is the byproduct of all of the hard work, the real work that you do in those quiet moments when you're alone reading a book or watching a video. So keep churning, keep taking baby steps, keep being frustrated and challenged and struggling with ideas until you grasp them, and be patient, but keep moving forward. So I sincerely wish you the best in your career. Thank you for watching.